deem it an honor to invite Professor Anjana Mukherjee, Director, Research and Development Cell, Central University of Punjab, to address the gathering with her welcome address.
A very good morning to all of you. Professor Ramakrishna Busrikla, Dean in Charge Academics, Central University of Punjab, Dr. Paramdeep Singh, Head Department of Radiology, AIIMS Bathinda, Dr. Shashank, Dr. Jitendra Patnaik, and Dr. Chetri Mayu, and other members of the organizing committee. It's really a pleasure for me, an honor for me to welcome you all and all the delegates who have joined us from different neighboring institutions. We have students from MRSPQ, AIIMS Bathinda, Central University of Punjab, Akal University, and I could see few people from Adesh University also. So it's really, these kinds of events, they help the students. This is mainly organized for students, and this conference has been organized by INIAS, that is Indian National Young Science Academy. Dr. Patnaik and Dr. Paramdeep Singh, they are the members of the, this is a prestigious membership. And we also have, in collaboration with Central University of Punjab and AIIMS Bathinda. Actually, we were expecting, this is of the patronage of our Honorable Vice Chancellor, Professor R.P. Tiwari and Director AIIMS, Dr. Singh. And they were expected to be with us, but being administrators, they have other assignments and they could not make it. But their blessings are with us. And this is going to be, I'm sure that for beginners and especially for students who are pursuing PhD, the deliberations, we have, roped in speakers who can help you with the basics of research methodology. Research methodology is very important because when you pursue higher studies or even at your postgraduate levels, this should be a part of the curriculum. So with that aim, this one-day national conference has been organized, and I also welcome, we have around 200 participants who are joining us online from different parts of India. So a large number of people there online, virtual, that has become also, a mode of joining such events after the pandemic has hit us. So I'm really, happy that we have been able to organize this, and I'm sure that with the efforts of the organizing committee and the students who have been working a lot to make it a success, I'm sure that you will have good messages to carry home. So I welcome you all again to this one-day national conference on basics of research methodology.
Thank you, ma'am. To give us an overview of the conference, I would like to invite Dr. Paramdeep Singh, HOD, Department of Radiology, AIIMS Bathinda, to give his introductory speech.
Good morning, everybody. I think ma'am has already given an overview of this conference. So this conference is basically sponsored by the Indian National Young Academy of Science, which is actually a part of INSA, Indian National Science Academy, under the Government of India. So we are having speakers from Central University as well as AIIMS. So there will be about 5 to 6 lectures, and each lecture will be about 30 minutes, which will be followed by 10 to 15 minutes question and answers. So I hope that you all will gain from this conference, and the knowledge gain you can use in your day-to-day research. And once again, I welcome you all. All the best. Thank you very much.
Thank you, sir. Moving forward, I invite Professor Ramakrishna Busrikla, Dean in Charge Academics, Central University of Punjab, to deliver the inaugural address.
So good morning to all participants to the National Conference on Basics of Research Methodology organized by Indias, and I'd like to first go with our patrons, Professor R.P. Tiwari, Honorable Vice Chancellor, and Professor Dinesh Kumar Singh, Director AIMS Bhatinda, for always encouraging us to have these kind of programs. And we had a number of collaborative programs with AIMS Bhatinda. So that is a really good thing that we are collaborating with all our institutions which are located in and around Bhatinda. And the organizing committee, Dr. Paramdeep Singh and Dr. Patnaik, and all the faculty members of geology and geography who are helping in the organization of this event. So it is good to know that there are close to 60 participants offline and in hundreds online. So research methodology is a key component, as Dr. Anjana Munshi said. In all academics, if you look at masters and PhD, and in this workshop, I am seeing that a lot of different areas have been covered. So how to conduct, what is the research design, how to conduct your research, how to write a good proposal, and what are the ethics that you need to follow. So it is very important to understand all these different concepts, because if you know how to write a good proposal, because you may be a PhD student or a postdoc, you will become faculty, you will apply for funding. So many people write proposals, but writing a good proposal will increase your chance of funding. And also when you are writing your thesis, PhD thesis, experimental design is the key. What is the hypothesis? What is the objective? And how you plan your experiments. Is your design sound or not is important. Because this will go to external reviewers, right? If there are issues in that, then your degree comes into question. And you want to publish in good international journals, again, a sound experimental design and how you are doing, what is your problem, these are all important. And equally important is ethics. So we do research, but ethics is very important. Without that, questions can come. We don't want to do anything wrong that will harm the people around you, the society, and if you are working with animals or any organisms, again, the issues come. So these are all covered in this workshop, which is a good thing. And I can see so many people attending this. So they will all benefit, not only themselves, you should also help others who don't have this knowledge, and other students in your institutions, whether you are coming offline or online, to help them, okay, go forward and do a sound research. I think it is the basic thing that we need for any degree. So with these words, I will move on to the next session, as we are already going late. So I really wish all the participants and all the organizers that this will be a very successful event. Okay, thank you very much.
Thank you, sir, for giving a wonderful start to the conference. It is an honor on our part to felicitate Professor Guzurika, for which I would like to invite Professor Anjana Munshi, Director, Research and Development Cell, to present the token of appreciation.
Thank you.
Sir, we can move this slide so that you can see.
Yeah. Maybe this can be put in his room.
Scientific writing is a significant skill that every academician needs to acquire during the course of their journey. It is an important tool that needs honing and proper training. The first topic for today's conference deals with the proper and efficient way of formulating scientific ideas into words. To share her insightful words on the topic, the art of scientific writing and project designing, I would like to introduce our first speaker for the day, esteemed Professor Anjana Munshi, who is currently posted as the Director of the Research and Development Cell and is the Chief Vigilance Officer at the Central University of Punjab. She was formerly the Dean, School of Health Sciences and Head of the Department of Human Genetics and Molecular Medicine in the Central University of Punjab. Along with having an excellent teaching record and experience of more than 20 years, Professor Anjana Munshi has around 150 publications to her name. Now let us invite on the stage Professor Anjana Munshi with a huge round of applause.
Screen share करको और
Yeah, so I have been assigned the duty of dealing with this topic, the art of scientific writing and project designing. This is very, very important, especially for beginners. No, how do we write papers? People write newspapers and other places, but writing a scientific paper needs a skill, which you have to learn over the period of time. And it's not only on the language and what way you communicate. The way a businessman sells his product, the same way we need to sell our research, in the sense that you need to communicate it in a better manner so that others follow it and they really appreciate that what you have done. So, if you define a scientific paper, it's a written and published code which describes the original research results. Whatever you do, you compile it. First, you conceptualize, and then you carry out experiments. There's a hypothesis which needs to be proven. So that's how you start with. So now if you have to write an effective research paper, there are various steps. The first thing is that you have to get ready with your data. Once you are conducting various experiments, you need to get ready with your data, and then you just compile the first draft. Okay, and after compiling the first draft, what you need to look at, what is the structure of a scientific paper. Scientific paper, it has a particular structure, introduction, then methodology, you have an extract. So I come to those, subheads of this one by one. Then after that, selecting a journal is also very, very important, because you have to look when you go. Currently, everything is online. You will see, go to the journal web page and see what is the aim and objective of the journal. So you have to see that whether your work that you want to communicate does it really fit in that journal. So they define the aim and scope of the journal very, very clearly. Okay, and then after that you submit, and you might sometimes it gets reviewed, and by 2 or 3 reviewers, they might ask for revision. So after you get revise your paper as per the comments of the reviewers, you revise it and you send it back. If they are happy with the revision, then they will accept the paper and they will send you a galley proof. Galley proof means before they publish it, the final transcript they will send it to you, so that you can have a look at it. And you, if there are any mistakes, sometimes some typos and all remain. So the ball is now in the court of the author to finally give it a green signal. Yes, you can go ahead with the publication of this. Now, if you go step by step, the first thing is you need to ask a question. Right? Whatever area you want to work, see whatever has not been addressed till date. And is there a specific question which we can ask? And once we that way, for that, wherever information is not available otherwise, so you ask a question based on the previously published literature. So lot of literature search has to be done before you actually ask the question. So because that gives you the lead that what is missing. After that, you as I said, that you have to do a lot of research, background research. You construct a hypothesis, test with an experiment. You also have to see whether whatever you have hypothesized and you say that I perform it using this experiment, it's not necessary it will work. So sometimes it might not work. You might have to see an alternative way of doing it. Okay. So you have to analyze the data, and your results should definitely align with the hypothesis. Whatever the question has been put, because when we write the introduction or the abstract, we say
the aim of this work was this, and we have to see whether that aim has been addressed by the results. Okay, and you also have to discuss. Right, discussion is a very important part of the paper where you will see that vis-a-vis what previously. Sometimes it's not necessary what you are seeing is in alignment with what others have already said. You can counter. You can say that it's not in line with what people have said. You can have two kinds of thoughts. So everything needs to be discussed. That's why background research is very, very important. Looking at the previously published literature. After that, this experimental data also, what you have generated now becomes your basis for your next step. Maybe you want to proceed further in that direction. You had asked one question that has led us to next level, and there we can proceed again in the same direction. Okay, so it's very, very important that if you have the data, you have to get ready with the data first. Okay, before you start writing, you get ready with the data. You can plot graphs, you can prepare tables, you can organize your results in such a manner that means I should discuss first this part of the result, then followed by. So there has to be a logical order, sequence that has to be kept in mind before you start putting it on paper. Okay, and you can also, there's a very good way of creating your own figures for the manuscript. Keeping the background things in mind, what you are proposing or based on what you have got, what could be the possible mechanism that you can propose by drawing a figure. We have many tools available currently that can be used. BioRender is there, we have ChemDraw. So you can draw your own pictures, because currently we cannot borrow anything from anyone without their permissions, because there are a lot of IPR related issues and all. So then you have to include edit. Maybe sometimes these days people are also putting some multimedia in, say how they put experiment, because you have to give supporting data, supporting tables, supplementary tables. People also take videos, small videos, and they upload it along with their paper, so that they will show that that how we have performed and how it has been done. Okay. Now, sorry. Yeah, so you have to identify significant 2 or 3 important findings which are emerging from your experiments. The central theme of the article has to be identified. Okay, yes, one thing is very, very important. Note the good and bad, writing styles in the literature. Sometimes when we read somebody's paper, we really don't get an idea. We are not able to follow it in a very proper manner. So write it in such a manner so that the readers are able to, you can yourself decide. When you read somebody's paper, you feel much comfortable and you get a very clear view. Others write it in that particular language which is not very, very clear to you. And then also, we also have to see the readership, not only the aim and objectives, readership of the journal. Who are the ones ultimately, takers of your research? Are these clinicians? Are these social scientists? Are they people from law or wherever? You can, as I told you, have prepare figures, tables, and other things. And also, you have to pay attention to quantification of whether your data is accurate or not. Okay, error bars have to be put, significant digits have to be there. So these are important things. Yes. So this is actually the structure that you have. First, an abstract, that is where you have title, the names of the authors, then an abstract, then keywords, introduction, like why giving little bit of background, why is it that we are doing this? Okay. Second is that what methods we have followed. Third is what results we have got. So why, how, what, and now discussion. So what? Okay. So, and conclusion is important, and references also, because you cannot, without references, your research paper is incomplete. You have to say, and you have to give, credit to each previous publication while discussion or introducing your subject, that I am writing this based on somebody's reference. It's not that I am saying it on my side, right? So if someone has said, you have to give credit to them by citing their these references. Okay, so this is how we also have to focus on acknowledgements. Acknowledgement is the last part where we will acknowledge either the funding agencies, or if sometimes some people contribute in your research by helping you carrying out certain experiments, but they are not to the extent that they can be given authorship. So for those people, we write acknowledgements, right? So we acknowledge, say, so and so has helped me in drawing this picture, or so and so has helped me in conducting this experiment. So that's how acknowledgements are, written. Yes, title is very important. When you are, because you start with the title, once you have conceptualized, you need to give a title to your paper. And that title has to be simple, attractive, and the words in the title, the title has only few words. So those words should reflect that what is it that has been done in the in this paper. So title and abstract are very, very important. Okay, actually people say that good research papers should avoid words like investigation, study, novel, facile, etc. You also have to avoid acronyms that are only known to specialized community. So for example, we geneticists write certain manuscripts, but they might not be the terminology which we use in the title itself might not be, the clinician might not be familiar with that. So therefore, you need to avoid such, words in the title. So, like for example, say we have recent advances in HER2-positive breast cancer epigenetics. Then we can also give a colon sometimes and say susceptibility and therapeutic strategies. So the title itself gives you an idea that what has been done in this paper. Coming to the abstract, the first few couple of sentences in the abstract should tell you that what is the study about. And you have to, include your way, because abstract is, there are also limitations by certain journals. They say only 300 words or 200, 250 words. So you must include major findings in a style that a general readership can read. Okay, and you have to keep it very short and effective. Keep it simple and informative, and be creative in generating curiosity. Write abstract in such a manner, because you cannot give all the results and everything. We just write 1 or 2 lines about the results. So write that in such a manner that people are then curious to go ahead. Because sometimes you just look at the abstract and then you don't feel attracted. You don't want to go further, like reading the paper. So the curiosity has to be generated. That's why I said this is an art. Okay, and you learn it over the period of time. You understand what are the best ways to put it, so that the readership increases. Okay, yes. So you can see that this is the abstract for one of our papers, the title, and then you have there are 2 kinds of abstracts. One is structured abstract, where you have to give purpose, methods, results, and conclusions separately. Okay, this is a structured abstract. There can be an abstract, some journals ask normal abstract. So you need not to write those subtitles. You just start with your background and keep on going. Don't give those subheadings. It depends upon the journal, whether they want a structured abstract or they want a normal kind of an abstract. Yes, keywords are also very, very important. Yeah, now you see, the previous one which I have seen is a structured abstract, whereas the one here is not a structured abstract. Okay, and after that, where sometimes some journals also ask graphical abstracts. Graphical abstracts would mean they will, for sure ask, draw a graphical abstract. So your drawing has to show what you have done, what was the background and all. So that kind of an abstract is called a graphical abstract. Yes, introduction, you have to put your perspectives, because you start with what actually you wanted to do, looking into the background, and ultimately become too specific what is it that you have done. Okay. Yeah, now keywords are very, very important, because every journal will ask you keywords. Keywords, you need not make them too general, because, for example, drug delivery, mouse, disease, or you even don't make these keywords too narrow so that many people do not understand it. The keywords have to be thought very, very, you logically, because whatever you are communicating, those few words should also reflect, not only the abstract, the keyword should also reflect that what is it that you are actually, what is it about? You know, just give those keywords, think about those keywords, because they ask only 4 to 5 keywords. So think about it very, very sensibly. Okay, now we have already talked about this. Yes, you know, if you have, don't excessively present your data. You can present everything in a very elaborate manner when you are writing a PhD thesis. But for for journals, some journals have also limit of words. Maybe some say only 4,000 words. Some say only 6,000 words. So therefore, you know, don't put excessive data. Give data in a very crisp manner so that it is communicated and actually the message is conveyed. Okay. Yeah. So you see, sometimes what we do is that we also draw figures on our own. Okay. But you need not, maybe you don't write too much, but whatever you have, you want to communicate, you can draw it in a picture and communicate. You can draw a figure and communicate. If you do not want to write, if there is a word limit, you can put many things in a figure and communicate what you actually want to say. You know, figures speak, visual impact, that is much more than you read and write, right? So that is another thing. Okay, yeah, you also have to have, you know, for example, you can sum up many results in the tables. For example, in this paper, we have summed up many things in the table. Okay, so that also is a way of condensing the words and not writing too much in the text, but communicating either in the form of consolidating your data in a table or consolidating your data, whatever you want to say, by drawing a picture. Okay, now yes, you also have to say, you know, give your own pictures what you have actually got, and they are there. You have to give, you know, proper legend to the figures. Legend would mean that you have to write what this figure is about, and those figures need to be quoted in the text. For example, here we have said figure 3, and if you are writing something, I say this is shown in lane 2 and 4. So that is how you can, you know, make it more impressive and effective by giving actual pictures also, and you can draw the pictures also. Okay, now you see, coming to the, you also have to do statistical analysis, because most of the data currently is not acceptable without carrying out statistics. Has become a very, very important tool in biology. No paper is accepted. I think that's true for social sciences as well. You do any kind of studies, you have to carry out a statistical analysis. So it's not necessary you do. See, joining hands in research is very, very important. So it's not necessary I know everything. I take the help of a statistician and ask him, this is my data, I want to analyze this, what kind of test. We have softwares available. Most of us use that SPSS, different versions, keeps on changing. You can carry out a t-test. You have many online softwares also available, where you just put your data and that analyzes your data and gives you the results. But then statistical analysis is very, very important, because no paper in biology, as far as I know in my subject, is accepted without statistical analysis. Okay. Yeah, so you can draw tables, as I said, that results are very, very important. You can consolidate many things. You have to, this is what, after statistical analysis, we have put a p-value, which tells us whether your data is significant or not, what you want to say. So that is how we put it on. And you also sometimes, you know, there are other softwares. Say, for example, this we call it as Manhattan plot. This is also generated by a software. So whatever we have observed, I put the data in this. This, for example, is for a genetic study where we are trying to see which variants, which alterations in the genome are more significantly associated with the disease. This actually paper was with the drug response. So you can see that some of them have gone up. You see here, you can see two, that brown one and then green one. So therefore, you know, you have currently, if you really want to get into the research, you have lot many other tools which can be used, and it should help you to interpret your data and present your data in a, this is a, you know, software generated picture only. Okay. Yeah, so you can also have, you know, other ways of putting it, like saying bars comparing the controls with whatever things you have done. You can draw and you can have those bars representing maybe various kinds of things. So that's how you can put it, drawing bars and figures, putting it in tables, putting your data and software, generating pictures which make it more significant in terms of interpreting your results. And discussion is very, very important, because unless and until you discuss your results, it's not going to vis-a-vis previous. It's not only papers are appreciated where you write it in the lieu of what already has been published, but what you have done, how do you think it? Okay, how do you interpret your results? So results sequentially, the way you have written the results in whatever chronological order, the same chronological order discussion has to be done. Each and every significant result needs to be discussed. Okay, you can propose your own hypothesis. Say, for example, what you have done is not known previously. You might draw a picture, say, I think that based on what has previously been published in the literature, I feel that it can be connected this way, these missing links, and this is what I have done leads us to the next step. And you also can give future perspective, how you will carry it further, right? Yeah, so we have acknowledgements. I said, yeah, references are important. As I said, that we have like there are various ways of different styles of putting up references. So that style is specific to the journal, and I will show you there are different those kinds of different kinds of styles writing your references. And we also have currently softwares for this also, arranging your references. For example, EndNote is there. EndNote is a software which helps us to arrange our references as per a particular format, as is required by the journal. Okay, so yeah, so I said that that is what I was talking about, that we can put your, say for example, here we are trying to say something and we have actually depicted it in a picture. The students have drawn it using different kinds of softwares, like this has been drawn with CamDraw. We also use BioRender. Okay, so that's how you can make it more attractive, more impressive, by just writing a couple of lines and trying to say from where you started and what is it that you actually got. Okay, so this is another way of putting it. Okay, so yeah, we have to do right, as I told you, at the end of it these acknowledgements. And people also say that conflict of interest, you have to make a statement, do you have a conflict of interest or not? That's important. Ethical approvals, because when you deal with animals or human samples, before you study, you have to take approvals. You have ethical committees. For example, in our university we have ethics for animal, that one committee is there, ethics for human samples, biosafety committee is there, where we they deal with recombinant kind, DNA kind technology. And we have to see that whether we are causing any, more, is it that we are troubling the patients or whatever. So that committee assesses all that, what methods you will be using, and if then only they will give you a clearance. Journals will ask for the clearance certificate sometimes. Okay, so that's also important. Okay, so conclusion is important. As I said, that you have to conclude ultimately you have to say in a couple of lines what has been, with what was started with just, and then what are the key findings, and how do you think it will be taken up further. Okay, so yes, some journals also ask author contributions. So you have to write, if there are 5 authors, it's not that just giving authorship training, आपके दोस्त है मैं आपका नाम डाल दूं, ऐसा actually journals नहीं चाहते हैं, although कभी-कभी हो भी जाता है, मगर we have to give actually we have to give which author has contributed what. Okay, who has designed the study, who has carried out the experiments, who has collected the data, who has interpreted the data, who has written the draft, and who has revised and finally brought it to that level that now it's ready for the communication. Okay, so yeah, now coming to the different styles of reference, we have the modern language association, that is MLA. For example, this way, You write first the author names, only last author name, et al. Give the the title, then say the name of the journal in italics. Similarly, you have APA, that is American Psychological Association, another kind of format. You have Chicago kind of styling, references, Harvard kind of style. So that reference is very important style. But like, how do you put it? Say, for example, there we have written Ludhyat Abhilash, Abhishek, Anjana Munshi. Here you have only the last name and the initial of the first name. So those are different kinds of, writing the reference styles. Vancouver is another one. Yes, I told you that EndNote students, our university everybody knows, but maybe students who are yet to go into research or they are yet to pursue their masters, dissertations, they can take use of this. They can use this software to help them, organize that. This is also, there is a trial, 30 days free trial, so you can use this without paying and analyze. Yeah, yes, plagiarism is very, very important. It has become an offense. If you take somebody's writing, even while discussing your results, you take somebody's lines as it is. So you have to, this is not taken. They say whatever you want, you have to put it in your own words, not repeat it in the same way what he has said or she has said, right? So therefore, there are also plagiarism detection tools. So before you communicate, please do this. Please check that your paper has been whatever, sometimes when they write, they just take 2 lines. They also look into 3-4 words together taken from a paper. They will highlight, so you will get a report generated at the end of it. So try to do it. Sometimes even if there are certain lines which have been repeated, you can modify them based on your report, and then ultimately, this ultimately you can communicate. But there should be no, copying from anywhere directly. That is not permitted by anyone. No journals also do plagiarism check currently at their levels also. So you have to be very, very careful. Not even a couple of lines or a couple of words together have been taken from a journal as it is. Yes, sometimes you have to see, I had published a paper and there we had drawn a picture. I wanted to use the same picture for another communication. So I had to seek permission from the publisher. Because once you give your article and it is published by the journal, you have to sign an author agreement form. So it becomes their property now. Even if you had done it, आपका उस पर कोई हक नहीं है. अगर आपको दोबारा, if you want to use it, you have to again seek permission. So without permissions, don't repeat figures, don't take anybody's text as it is. Okay. So yeah. So now next is how to select a journal. So a proper choice of a journal, I talked about it very, very specifically. You have to look at whether you want to have a specialized area of journals. So for example, I work on neurodegenerative diseases or cancer. So I will choose some journals which are very, very specialized in that particular area, rather than going general molecular biology journals, because there the inflow of papers is many people send to those general kind of where it can any area of molecular biology, whether pertaining to plants or animals or any other area is communicated. So therefore that choice is very important. And then yes, this is important, that what is an impact factor. When we have many times interviews conducted, even some senior faculty members do not know what an impact factor is. So, impact factor of an academic journal, it reflects the average number of citations to recent articles published. They publish the impact factor every year to a particular specific journal, okay, for a particular year. Actually, it is also used as a metric for the relative importance of that journal or impact of that journal within its field. Okay, so therefore, journals of higher impact factors are needed, therefore noted to be most important and influential. Okay, now you can, I just see here, total number of times its articles were cited during the last 2 years divided by total number of citable articles in the journal during these 2 years gives you the impact factor. Okay, so you can see some of the journals have even 42, you have 15, 56. So some journals have high impact factor, but publishing in an impact factor beyond 1 or 2 is also very, very difficult. So you can understand the level and the content of the research that is required to publish in a high impact journal. Like you have New England Journal of Medicine, you have Lancet. Another thing which we must know is H index, and H index is very, very important. It is calculated by counting the number of publications for which an author has been cited by other authors at least the same number of times. So an H index also, for example, 4, 5 also takes time to get. Okay, so therefore having higher H index means that author is publishing very well and his papers are cited quite often. Okay, so yeah, there you can write there in the beginning the names of the authors, and sometimes they don't ask you on just on like on the top. Some journals publish it on the left hand side, and there is also an asterisk for the corresponding author and his or her address there. Okay. Yeah, so see, for example, here you have on the left hand side, like who is the person you need to do correspondence to. So here it is on the left hand side. Okay, these are the impact factors of journals, higher impact factor journals, some of the journals. Yes. Then submission, as I told you, the final paper has to be read very, very carefully, check for accuracy of figures and captions, and then I told you referring the figures in text is very, very important. Okay, get feedback. You can also give it to your senior colleague and take his or her input. That is important. You have to provide a cover letter to the editor saying that just a brief paragraph, what is the importance of your paper, why do you want to communicate it to his journal. Okay, now and ultimately submit the paper online with copyright form. There's a copyright form which we, because I told you it doesn't remain anymore your property, it becomes the property of the publisher. Yes, then if the like reviewers are, sometimes reviewers give very healthy comments, and you really improve your submissions greatly once you read their inputs. So it makes you to even look for more literature. They'll ask you what could have been this, what was this, why not this, why less, why more. So those kind of questions make you become more inquisitive, and you learn over the period of time by the comments of the reviewers that what should be the way we must communicate our next paper. Okay. Yeah, you can submit your revised version and you have to write a rebuttal. So, for example, हर एक question जो उन्होंने पूछा है, you have to write a separate document, response to the reviewers' comments. So each and every comment you have to defend, okay, so that document goes along with it. Okay? Yeah. So if sometimes, yes, this is a very common practice, and many times we are very enthusiastic. We send it to the journal. Many times, editor himself says it's not very suitable for our journal. So at that time, you don't need to get discouraged. Many times after they send you the reverse comments and say, now we don't want to accept it because the reverse have raised these concerns. So it's actually a feedback for you. You can revise your paper based on those reverse comments, send it to another journal. Okay. So you need not to get discouraged if it comes back. Okay. Now that's all about writing a good scientific paper. And just go hurry, I do not want to take a lot of time, is it? Huh? Okay, I will write how to earn a research grant. Okay, so earning also a research grant also is very, very important. That you have to look at there are many funding agencies. These days, unless and until your research has some application, we do not get funding. Funding is important because if you do not have money, you cannot carry out research. So it's important for us to write your grant in a very, very important manner, wherever you can take the help of your previous colleagues who has already, if you are beginners, take a sample, from them that which one has earned you a grant. So they will help you. This also has almost the same structure. What are the objectives? What are the methods to be followed? What is the expected outcome? So all that has to be compiled. Vis-a-vis is the previous literature. What is your national status of that particular topic? What is the international status? Everything has to be taken into consideration. Okay. So therefore, here you have to identify need and focus. Find what are the prospective grants. Everywhere there are many agencies who give a call for specific grants. So you can keep on looking for that. Okay, you can prepare your specific proposal, submit your proposal before the your deadline, and then if you get it, you carry out the project and the filing of report and also submitting a utilization certificate, because whatever grant they have given, you have to give them an authenticated certificate that how you have utilized your grant. Okay, there are various funding agencies. I will just go through hurriedly. Say for example, DST CERT, Science and Engineering Research Board. We have they have their own web pages. You will get every information on the web page itself. Okay, for example, Indian Council of Medical Research is another one. You have they will also write what are the extramural research projects, international collaborations, fellowships. Everything is on their web page. You can click on whatever is required and go go into that web page. So Department of Biotechnology is another funding agency. You have for example, they mostly building capacities. They will give different kinds of mission programs are there, which are carried out nationwide by collaboration of various institutions. Okay, Department of Health Research is another funding agency. Then you have BIRAC is there. They generally give for what you say the entrepreneurships, translation research. You also have ICSSR in case of social sciences research. CSIR is there. Then they have different schemes which are projected on the web page. They also write what is new. Okay, so you have Ministry of Ayush. Okay, you have Indian National Science Academy. They also fund some research like projects. Dr. Patnaik and Dr. Paramdeep, they know. Okay, you have AICTE, they also fund. Okay, so you have various kinds of DST is there. You have various kinds of funding agencies. Like there are guidelines, there are pro formas, there is a way how you write it. All that is depicted. They will give you, it will take you to that web page and they will show what should be the pattern, how you will put it together. Okay, so that's all. Thank you very much. I'm on time. Okay. So if you have any very hurriedly, I can take one or two questions from the students.
Online also you can ask.
Yeah. So if anyone online has a question, maybe we can take it. They can write it in the comment box and we can answer. You have something to ask?
Actually, I read that structured abstract model and basically.
I will tell you. Structured abstract means when you have to write what is your background, introduction. You have to write that on one side. Methodology, then results and discussion, and then results and conclusion, then keywords. The abstract which is not structured, you need not subdivide these subheads. You can just keep on writing just one paragraph. Graphical abstract would mean where you have to put your thing in a pictorial manner. Okay, you can say that in one box or in one, this thing you will show that this is everything will be depicted by the figure. The methodology and everything will be depicted in the figure itself, and what is the expected outcome will be in the figure. Single picture is the graphic. They ask sometimes both. Maybe an abstract which is written and a graphic. Yes. And
More graph or any kind of diagram.
yes, with diagrams, definitely tables. Rather than writing volumes together, it's better to consolidate your findings. And somebody looks in your table, they grasp what has been done in just one go.
they need not to read, टेबल में सब दिखता है या फिगर में सब कुछ दिखता है, आप उसका लीजेंड पढ़ लीजिए, आपको पता लग जाएगा. So I think those are effective ways of, you know, putting your research in a better manner.
It's an online. Yeah, बोलो.
Am I audible? Hello. Am I audible, ma'am? Hello.
हमने उनको मैसेज डाल दिया, मैसेज सीधा क्वेश्चन कर.
अच्छा,
Hello.
आपने
He raised hand, but
Hello. May I?
No question.
no
Hello.
question.
That's a low question. So I think, yes, please.
Hello.
Gallic proof is, yes, I will tell you what, you know, once you communicate, because you don't put it in that form, the way it is published in a journal. You know, they have their own style of putting your, they use different styles, their fonts are smaller, you might have written 10 pages, they will consolidate it 4-5 pages. जैसे printing में आता है, that is, before they print it, actually they put it in the journal format and they send it to back, that is called as Gallic proof. कि अब आपका पेपर जर्नल में ऐसे दिखेगा. So if there are any mistakes at that time, also minor mistakes, you cannot change. अब मैं results बदल दूँगी, that's not, you know, possible at the level of practical this Gallic proof. But if there are any typos or any small mistakes, you can mark them and you can communicate. They will be rectified and they will be published.
किसी चीज को हमने डाटा को पढ़ा, उसका हम टेबल बना रहे हैं, तो वो डाटा टेबल हम शो करेंगे, उसको भी हम फ्लैक्सिबल में मानेंगे.
नहीं, जो आपका अपना डेटा आपने टेबल में डाला है,
नहीं किसी डाटा और मतलब किसी और साइड से
नहीं, अगर आपने 4-5 जगहों से लिया है, आप उसमें टेबल में डालिए, मगर साथ में रेफरेंस में एक ऐड कॉलम करिए रेफरेंस. ओके, डोंट टेक इट एज इट इज टेबल. आप वैसे लेंगे कि किसी ने बनाया. अगर आपने 10 ऑथर्स का डेटा मतलब कोई फाइंडिंग एक टेबल में डालना है, तो आप लीजिए, मगर आप उसको अपने वे में टेबल को बनाइए और रेफरेंस जरूर दीजिए. हाँ, यस.
What is the minute difference between abstract and a conclusion? Because recently I'm writing a paper, research paper.
You see, abstract, it will have everything right from your background, introduction, methodology, and ultimately results. The conclusion is just a couple of lines that in conclusion we say. They will not repeat introduction and everything. You say in conclusion, this research highlights or this says this and this is related and this is not related. So conclusion does not include all those things.
What's the threshold for availability?
What is the threshold? So it is 2% present child PhD thesis में 10% allowed होता है. Tools you have, we have many softwares available. That is, Turnitin is there. We have another one is Grammarly doesn't give one. Good is there. Those are the softwares. No. Writing a review paper, you write a review paper. Write those findings in your own words. Give a reference. But you don't repeat. So, for example, I said, I found this like this. You don't have to repeat it as. You can say, I found so, yeah, or it has been reported that this is how it has happened. So, then give a reference. So, review paper में आपको सबसे permission लेने की जरूरत नहीं है. मगर उनका जो लिखा हुआ है उसको as it is produced नहीं करना. Yes, after the publishing, once it goes that's why you have copyright form to be signed and submitted to the journal. Right, मतलब आप ही author रहेंगे, वो author ही बनेंगे, reference आपको ही मिलेगा. मगर अगर आपको उसमें से कोई चीज use करनी है फिर से, तो you have to take permission from the publisher. Yes, I said no. Mostly journals don't. Self-plagiarism भी आजकल allowed है. You can put your research, whatever you have done previously. We say that as per our previous work conducted in our lab, these are the findings. Give a reference. So you cannot repeat as it is what you have done previously.
So see, there is a reason you are asking. So there are different softwares. Okay, one is Turnitin and then original what are the Notebook. But in Urkut, if you get 5%, the same thing you use in Turnitin, it will give much higher.
Yeah, then
Okay. And journals use another software which is more
Ma'am,
so it is better to be on the lower side, 1%, 2%. If you have 9% on something, the journal when they use the software, it will become 15% or 20%. And also in that software, there are how many words are you
Yes,
looking?
in-
Okay.
Continuous.
Then continuous, whether they are 8 words, 10 words, 12 words. So journal also they have this many words. So you need to look at that. If you are using 12 words, journal is using 7 words, your 8% will become 18%.
And even
Okay, so all this-
sometimes technical words also they highlight. Say I say hypertension. It has been used, so you have to defend. You have to say that these are technical terms. I have removed rest of the plagiarism, but these cannot be changed. They have to be used. Those specific words have to be used as it is.
Ma'am, you mentioned some of the words like investigation or something that are not very good in search. So is there any list or something there? Because-
No, it's not. That is, they just say that avoid those. Better is, give something which takes it more. Investigation, everyone will write. Right? So, right.
how do you judge that which word should be added?
You will learn it, look at some of the publications where references and all, you will get an idea. And when you grow in your research career, you will understand. You will learn, you will gain that skill.
Ma'am, there is a question from Nida Karasi. Can we take data or theory or tables from books and put reference of that books?
Not as it is. Not as it is. No, we cannot take it as it is. Yes. You can either, reconstruct adapted from. Say, put your table in a different manner and say adapted from. But you cannot take it as it is. That's not right.
Thank you so much, ma'am, for an informative talk. We surely take great knowledge with us. As token of appreciation, I would like to call Professor Surika and Dr. Paramdeep Singh to facilitate Professor Anjana Munshi.
आप इधर चाहिए ठीक है थैंक यू सर
Before the commencement of the next session of the conference, I would like to invite all for a group photograph, for following which we can have a cup of tea. And I request all the participants to get back in 15 minutes so that we can start, we can begin with the next session. Thank you.
It is my pleasure to welcome each and every one of you to the next segment of the conference. After such an informative talk on the art of scientific writing and project designing, it is time to move on to the next topic, good research designing, which will be given by Dr. Sesade Bapani, Assistant Professor of the Department of Education, Central University of Punjab. Dr. Pani specializes in mixed method research, higher education policy and planning, educational measurement and evaluation, and curriculum planning and development. With a total of 16 years of teaching experience and an additional 8 years of administrative experience, Dr. Pani has also published 50 articles in both international and national journals. Amidst a huge round of applause, I would like to hand over the stage to Dr. Sesade Bapani to share his thoughts on the topic.
Okay. सबको नमस्कार. Good morning to all present here. My respected Professor Andana Madam, respected Professor from AIMS Bhatinda, Parambir Singh ji from Bhatinda, and Patnaik ji from the Department of Geology, and all the participants present here. I am fortunate enough to stand before you all to share my thoughts on how to select the good research designs. You all are the research scholars present here, and for the development of the country, it is highly essential to select the most appropriate research designs which will have certain community significance and which will yield appropriate significant result for the progress and prosperity of the nation. So being a social scientist, I will have my own viewpoint on different aspects of how to select a good research design. Before a formal discussion on the research designs, it is highly essential to understand what research is, what are the fundamental qualities a researcher should possess, and what are the characteristics of the good research designs, and how to select it also. If we the researchers will not be aware about all these aspects, then our research will completely be meaningless. So therefore, a knowledge and thorough understanding on all these aspects is quite essential. So therefore, I would like to, I do not tell you that within this 30 to 40 minutes discussion, I can make any magic so that you will be very much skilled in different designs, but I am sure that you will be able to know that how to select a good research design. So Before that one, we should have a thorough understanding what research is. Wherever we are right now, it is only due to research and innovations in different fields of knowledge. You just imagine where we were up before 10,000 years back, and what was the societal pattern there, and what was our health system.
Find a viable answer to that question. And posing a question, finding answer to the question in between, whatever you do, that is your research process. And important is what design we are following. So research, what it does, I'm not giving much time to this aspect. You all know. Research always it adds to our knowledge. It modifies the existing knowledge. It informs policy debates.
Okay.
And it controls and predicts the phenomena. These are the fundamental aspects of a research. And a researcher should conduct research not only for getting a degree, but his research endeavor should be directed towards these objectives, primary objectives. If so, definitely it will have certain significance for the society. It will definitely yield something for the quality of life of the people. So now, in our journey for this 30 to 40 minutes discussion, I think nowadays, in many cases, the young researchers, they should know. Actually, what should be the quality of a good researcher? Because these things matter a lot in the process of investigation. Because many cases, what is happening with the researchers want a shortcut approach to our research. And whenever there is a shortcut approach, you may succeed temporarily. You may get certain manipulated result, but that result will not be that much beneficial for the society. So therefore, if a researcher will focus upon these qualities, he can be a good researcher. And these qualities will help you to select a good design. Inquisitiveness, thirst for knowledge, analytical ability, innovativeness, adaptability to what you are innovating, what you will innovate through your research work. What is innovation? Looking the things in a different way. You think about the great scientists of this world. They have only been able to innovate because they are having these qualities. Perseverance, collaboration, communication, integrity, most vital quality of a researcher. Because this will only help you to reach at a conclusion which will have a far-reaching consequences for the society. So therefore, every researcher should keep in mind, sir, they should introspect themselves. They should ask this question to themselves, whether I am having these qualities or not before the start of the research. Because the research is not simply submitting the thesis and getting a degree. It's simply wastage of time. This is essential, but contribution to the field of knowledge, to the society, is also that much essential. Now, prerequisites. So, whenever we are thinking that let us follow a good research design for our research. So, how to select that one? Certain fundamental good research designs. What we will say as a good research design? That design of research will be called as good research design if that design is capable of extensively review the literature. So review the literature. Don't be tired and after 5, 6, 10, 20 review, which mainly happens in many cases. What is the purpose of the research? Ask this question to yourself. Why are you conducting research on that particular problem? What exactly you want to find? What are your objectives? Clearly specify it. And what resources are available with you? What resources? Manpower, machinery, your knowledge, your skill. These are fundamental aspects. Those determine that which research you will follow and which you need not. A good research design, basically, it will evolve from these aspects. Like you start from Identification of the problem, go towards the getting the purpose of statement, research question, hypothesis, nature of the sample, yes. Very vital. Nature of the sample. Where you want to conduct the study, on who will be your sample, what will be the number of your sample, what is the age of the sample, what are the characteristics of your sample. Consider it very critically. Analyze it. Accordingly, your design will be decided. Nature and type of data you are going to collect. Are you collecting quantitative data, or you are collecting qualitative data, or you are mixing, or there is the need of mixing both quantitative as well as qualitative data. From whom you are collecting the data? Urban area and the rural area. Where are you collecting the data? So these are certain aspects. Accordingly, designs will come to the picture. Challenges. What possible challenges you are supposed to face while conducting the research? So many things will come to the picture. Financial issues may be there. Skill related, your own skill related matter may be there. Resistance of the people may be there. And whether you are capable to access the sample, the data from different bodies or not. So many challenges will be there. Even if your personal challenges will be there, personal life related challenges will be there. So consider all these things. Otherwise, simply being over ambitious, if we are planning the research design, but in between, if you will face the challenge and problem, if you will stop or if you will be diverted, then it is meaningless. And duration of the research study. So these are certain aspects. Those are responsible for the selection of good research design. But you have to think the researcher very often what happens. I feel we become very much casual in our approach in considering all these aspects. So I request the young researchers to be very much serious on all these aspects. It will help you, it will lead you towards successful research. Certain things. Here, in many cases, the scholars commit errors. Research problem, purpose, objective statement, and research questions in deciding all those things. I am not going in detail, but simply I will highlight the problem before researcher is to have control of suicidal cases among adolescents. This is the problem before me. Why it is increasing? How to control it? This is the problem. Challenge. And my objective is to identify the factors responsible for it. I have to explore what are the factors responsible for such phenomena. And my research questions will be, I will now speculate on the basis of, maybe on the basis of earlier evidences or on the basis of my intuition, my experiences, consulting with the experts from different consultations, manifold consultations, I may think of the possible solutions. If I arrive at, then it is okay. I have to test it. Otherwise, put a research questions one by one, just by thinking, is over academic expectation, as I have noted here, is it responsible? Or any other 1, 2, 3, 4, go on formulating research questions. So very often, what happens? We commit errors here. When we commit here errors, our entire research process becomes futile. Our exercise becomes futile. For example, when I was interacting with the student of the science department, once upon a time, what happened? She told me that she was doing research on cancer patients. What happened? One of her research question was just to study the effect of medicine A. Suppose name of that medicine is A, or intervention is A, on the recovery from that particular disease. So what happened? That was her objective. So he collected the data. So when collecting data, what happened? He simply interacted with the such patients, verbally she interacted, and she collected the data, whether they are feeling well after taking the medicine or not, what is their reaction, what is their perception, so on so. And she concluded and we arrived at a conclusion. But here I would say that is simply one intervention of the medicine and its impact. So that can be, it is okay, he found or she found, he interacted with the patients just to know their reactions, it is okay, this is one aspect. But another aspect should be actually whether it created any change in his body or not, whether it reduced that particular phenomena or not, that incident of cancer, that disease or not. That should be medically tested. That finding should be there. Perception, reaction, whatever you are doing, that should also be there. So there should be the combination of all these things. But if we will wrongly perceive the research question, if we will wrongly analyze our research questions, then we are committing the errors. So that is why how we are formulating the problem, how we are formulating the questions, how we are collecting the data as per the requirement of the research questions, these are quite essential. We cannot ignore them. So that is why they all need what? A careful analysis, which I was telling just for a few minutes in my section, that is when I was telling the characteristic of a good researcher, your perseverance, your analytic ability, your integrity, they all matter. So we should not be casual at any point of time for the sake of submitting the thesis to get acknowledgement. So while selecting the research problem, we should also think all these aspects. Okay, like access to people or sites, what is the time, what is the locating resources, skills, should the problem be researched, whether I can have access or not, is it worthy to research or not? These are certain aspects. Whether the study of the problem, if a study will fill the gap in the existing literature, then you go for study. These are certain important things which you might have read at your coursework level, at your professor level. Simply I am highlighting, I am simply, my job is just to recall with the people, to aware the people about all these aspects. I am selecting a problem. And basically, the research designs, we classify them into two broad headings. We say quantitative approach as well as qualitative approach. And in sciences, actually, we are more concerned with this quantitative approach. And very often we go for qualitative approach also. Whenever, suppose you are studying the lifestyle of the people of a particular village that leads a particular disease. So it is both quantitative as well as qualitative also. Because you are interacting with the people, you are interviewing the people, you are collecting their information, the information about that particular disease or something like that in a narrative form. So whenever you are getting that in a narrative form, that will refer to your qualitative approach. And whenever in a number form, okay, numerical aspects are there more, your quantitative approach is there. But basically in sciences, the majority of the researchers, they focus upon the quantitative aspects. And whenever we are focusing upon such type of research, we have to think about these characteristics. You may select any design, no issue. First design is not selected. First focus is on the research problem. First focus is on the research proceeds. Focus is on the sample. That will propel, that will encourage you which design will be best for me, for my research work. So whenever you are designing any design, your focus should be upon the validity, reliability, objectivity, generalizability aspects of your research. To what extent this design is going to yield a valid result, whether you can trust upon your result or not. But validity of the findings, reliability of the findings, generalizability of the findings, the external validity of the findings, to what extent your findings you can generalize to the larger population, that depends upon the process that you are following. It means how you have collected the data, how properly, how you have analyzed the data, how you are interpreting the data. If you have followed all the research integrity and the correctness of all the procedure, then definitely the things will happen. And whenever you are thinking about the qualitative aspects, these aspects, credibility, transferability, dependability, replaceability is also another most important concern in case of research. Whatever data you have found, just think on it. To what extent they are correct? To what extent? What is your own viewpoint? Have introspection on it. What I have done, where I have committed the mistakes, what are my limitations, what are my strengths of my research work. That need to be analyzed. Yes. Usually, what happens in case of conducting the research, especially in sciences, we more focus upon the experimental designs. And so far the experimental designs are concerned, basically what we do, we simply test the effectiveness of one variable upon the other by controlling certain extraneous variables. That usually happens in a controlled condition. And any experimental research, it may be social science, it may be science. Basically, they are having certain fundamental characteristics, like your random assignment. Because if you are formulating, suppose you are preparing one experimental group as well as a control group. In the experimental group, suppose you will select a sample for that sample or the subject for that experimental group intentionally, purposefully you are selecting the sample. But that depends on whether you will purposefully select sample for the experimental group or randomly you will select. That depends upon the objectives of the study. That depends upon the objectives of the study. So that is why, while thinking about the experimental research, please focus upon these characteristics. If these characteristics are properly met, then we will succeed in our experimental research. Control over extraneous variables, manipulation of treatment, outcome, how we are measuring it, pre-test and post-test. We are giving pre-test, again we are giving post-test, in between intervention, whether the pre and post-test they are same or they will be different. If they will be same, then what is its reliability, test reliability, or whether the tests are equivalent or what is that? We have to see. because there is every possibility of interaction in fact between pre-test as well as the post-test. We should be very much careful. What will be the interval between pre as well as post-test? For how long time will be given? So these are certain fundamental concerns. Different designs are there, and sir was indicating, I think time is. So what to do? Anyway, just give me 2 to 3 minutes. I'll try to wind up the matters. So, in the experimental design aspects, so basically we are having between group designs as well as within group designs. I'm not going for a detailed elaboration of all these designs. I'll just scroll. Correlation designs are also there. If at all you are thinking of finding out the relationship between two variables, we can jump into such type of designs. Explanatory designs are also there in research, where two variables, whether they co-vary or not, whether one is responsible for a variation in another variable or not, if he is responsible, then to what extent its impact, these can be found. And predictive designs are also there, how one variable is predicting the future success of the failure. And survey designs, usually very rarely we use it in sciences, but there is also, we should not say that it is not used, but it is used, but rarely. If such mass survey work is essential, and these are certain aspects or category of the survey designs, longitudinal, cross-sectional, so on and so. And diagnostic design, basically it is used the validity, reliability of the data and all the things. So here there are different ways. Suppose credibility, we'll talk about credibility. What is credibility? To to how extent the findings are credible, to what extent we can believe those findings. Time pressure, very interesting characteristics. That means, suppose I am asking about that Mr. A, whether what is his behavioral pattern. I will ask Mr. B, tell about Mr. A. So whatever information he is giving, why shall I believe? He may not have a good contact with Mr. A, that is why he may speak something negative. So I have to ask Mr. C, Mr. D, his peers. I have asked, explore certain information from his teachers. I have explored certain information from other people, those that directly or indirectly concerned with that person. So in that way, credibility, transferability, these are different characteristics of your qualitative research.
Okay, thank you, sir. There is one more question here. Sir, please elaborate a little about inception with respect to diagnostic design.
Okay, so in case of a diagnostic research, just come to that slide. For that one. Okay. In case of a diagnostic research, what happens? It undergoes through these three major steps: inception, diagnosis, and your solution. Inception, starting point. What is there? What is the problem? What is the nature of the problem? Who are the sufferers of the problem? So identify the problem. That is your inception. What are the fundamental characteristics of that particular problem? Defining the problem, identifying the problem, defining the problem, understand the nature of the problem, understand the persons who are suffering the problem. These are the preliminary aspects that will your inception. And after that, your clear knowledge and understanding of the problem, you are going for diagnosis. Because your preliminary verification fails to provide you complete idea about the cause of the problem. So then only you will go towards the diagnosis. You are conducting a detailed diagnosis either in a social phenomena or through a clinical method. From different way, you can go for diagnosis. You can use certain tools. You can make certain interventions also there. And after that, on the basis of the diagnosis, you will be able to know what are the root causes of the problem. Then only you have to provide certain measures for the improvement of that problem. That will lead towards a viable solution of the problem. And diagnosis research is they are conducted where the problem is more critical, where certain interventions are more needed. I hope the participants may get scoring to certain extent.
Thank you, sir, for guiding us with such knowledgeable words. As a token of our respect, may I please invite on stage the members of the organizing committee to extend the felicitation to Dr. Cecilia Khan.
Thank you, sir. Thank you for accepting. उस तरफ भी देना होता है, उधर भी लोग देख रहे हैं ना. Thank you.
The next speaker for today's event is Dr. Sudeep Chakrabarty, who is presently an assistant professor in the Department of Computational Sciences in the Central University of Punjab, where he teaches the theoretical aspects of biomolecular hydration, surface aggregation, 2D membranes for molecular separation, and the development of polarizable and charge transfer force fields. He will be addressing us on the topic, the role of search engines in the present day research. Please join me in welcoming Dr. Sudeep Chakraborty to take over the stage and share his words of wisdom.
First of all, good morning. So, just, so first of all, I thanks the IMYS Central University of James Hotel.
आवाज नहीं आ रही है तो
IMYS for Pacific enough. And then would like to thanks the pillar of the two institute, Professor R. Raghunath Puttiwari, Vice Chancellor of Central University of Punjab, and Professor Dinesh Kumar Singh, Executive Director of SIMS Vatinda, and the organizing committee. First of all, I like to thank Professor Ranjit Mishra, Director of Awareness Central University of Punjab, and the Patnaik sir, who is invited to present a short story about the research. And also like to thank Parmjit Singh, who is the organizing committee, and the other members, Dr. D.S. Blitzer, and Krishnakant Singh, and Rahul. So with this, I'm just going to start about the role of search engine presentations. So when here, in the beginning, I would like to say about my journey in my research. So when I started my journey after just finishing my master's in 2003, so online from so during this time, my boss has asked me to go library and search journal. Library really लोग तो बोलते थे मंदिर जैसा था पर मेरे लिए तो डरावना था. When I just entered into the room, I found that several number of books, literatures, many things are there, but it is difficult for me to find out that which problem my boss is giving to me, to identify that with that literature. Because in the library, that the number of books, and you have to find out the number of pages, identify that, which is a big task during the year of just before 1990. So just before the boom of internet. So after internet has come, so we have many relaxation about the literatures. So first of all, when we were, let's say, example, Professor Anjana ma'am has talked about the research problem and the paper writing part, and Dr. Bansal has about the how to design a problem. But here, my observation is you have to find out the exact gap between which has published already and which you are going to do based on your topic of research. So suppose, example, my boss is given to me that biomolecular hydration. So in that biomolecular hydration, there is a number of words. In biomolecules, that protein, DNA, and the other macromolecules also. In the hydration, since the water, the next part is water. So I have to search with those keywords. But some of the time, if I mislead, if that term, other than that only in biomolecular hydration part, say protein, DNA, and the macromolecule, and the water, so that will give us approximately thousands of articles published at the time in 2003. So it is very, very difficult for me to identify that particular article and start my research. So that is why that searching in that time, that Google is there in the literature. So मेरे लिए तो वो अच्छा था कि Google भी है and the other search engines are there. So कुछ तो ढूंढ सकते हैं वहाँ पे. Then when I start the problem, so with the jumble of keywords, whenever you start your research, at that time you have to very narrative about your keywords and very specific about your keywords. Because with these thousands of articles, it is very, very difficult for me to identify my problem. So nowadays that internet is there, so nowadays research is kind of like a demand from the company, what they are demanding, and you have to supply. And it's a very specific nowadays, the research. And then you have to basically find out that the particular gap between which is published and which you are going to do based on the market demand. And basic science nowadays also the funding agencies are also looking into that whether your research is applicable or not. There is a good number of people are basically based upon citation also. I'll discuss about discussion. So that in this way, if I'm looking into the literature survey, which is an integral part of your research. So most of the cases, I would like to suggest whenever you start your research. So based on the literature survey, one can write an article, just a review article. That will give you a publication, and as well as some room that you will have a publication in your first year. Because if some experimental fellow is there or some theoretical fellow, obviously to start your original problem takes some time, approximately 2 years. So, and during this time, we are now adopted that word publish and publish. So if you are publishing, it's okay, otherwise. So to follow this word, everyone has to publish. And during your literature survey, if you are having a good knowledge about your literature, so one can write an article. Just to start the initial point, that one is a review article with a good start in your research. And as well as that whenever the original publication will come out, so during this time you will not feel bad that I'm not having any publication. Rather than to publish multiple number of journals in particular year, it's a very good way to start individual year. You are having some publication. Okay. So, in my discussion, the first part is the concept of search methodology. Second one, I will discuss what are the search engines, importance of search engines, and then I will discuss the category of search engine and use of the search engine in a normal daily life research and as well as in the research. So in this concept of search methodology, one have to be very specific about the keyword, which kind of problem they are looking to find out the gap. Now, just I am defining the what are the search engines. So I have written that search engine basically a software package, which is basically designed for information or extract information from World Wide Web. And that the search engine are basically following, basically looking certain keywords, and which are basically presenting into a database, man-made database, or basically or present in a library or present in other sources. And in what's the importance of the search engines other way? Suppose some government article, government policies, government database are there. Suppose someone is working on the economic policy. So in such cases, those document and databases is difficult to keep a track or record in your library. So such databases are available online. So if you are using certain search engine, I'm giving you an example of search engines. So search engines, one can get those databases or access those databases very quickly. And among them, one can basically track their particular part among 100 or 200 page of content. So in the common way, the common search engine, if you are talking about, couple of search engines are very popular among the World Wide Web. The first one is the Google. It's a very popular. Netscape, Yahoo, AOL, MSN, and RSC. So those are search engines are for basically daily life search engine. Suppose one can look into Friendific, like IRCTC, you will get IRCTC database very quickly. But how they are basically that Google is searching those databases and come to it. In the case of research, suppose someone is looking into the databases. Among the databases, the important databases are Scopus, Web of Science. PubMed is very common for biology people as well as for chemistry people. ERIC, IEEE is basically mainly for engineering people. IEEE transaction and other, this one is a very big database. Another database I have not mentioned, that one is the American Chemical Society. That one is a journal as well as a database too. Science Direct and DOAJ. This Science Direct is basically a very huge database which people are using to start their research. And if you are basically made a simple type, I'm bringing the name protein DNA interaction or protein-protein interaction, you will get thousands of articles from Science Direct itself. That importance of search engine. So in our literature, basically, approximately more than 10 billions of data articles are there.
Little bit louder because we have a lot of people joining us online.
Okay.
Yeah. What does yours say?
So the importance of search engine. So if you look into the World Wide Web, contains approximately more than 10 billions of articles or say newspaper journals to basically to do search within a couple of minutes. Without the search engine, this is very, very difficult to do. Very, very difficult to contact. So that one is a major importance of the search engine. Just to find out if your net connection obviously there, then one can connect and identify your article which you are looking for within a couple of minutes. These are the categories of search engines. So the first category is basically the crawler-based search engines. Some of the time people are saying that it's a spider search engines. Second one is the directory-based search engines. Third one is the hybrid search engine. And the fourth is the data search engine. So first one is a crawler or a spider-based search engine. Google and Yahoo, if you are taking an example, Google and Yahoo are basically both are come under the crawler-based search engine. This crawler-based search engine, some of the scientific databases also come under the crawler-based search engine. Say ChemSpider as well as SciFinder too. But the most popular one, Google and Yahoo. Those two are most popular search engine. If you look onto the Google page, that one is a single window. One can search, you can search your basically database which you are looked into. So you can type that and you will find out from Google. But along with this simple Google set, Google has other tools too. Google Map, Google Books. But most of the cases we are basically familiar with this simple Google term. So in your mobile nowadays, obviously people are, the companies are already loaded that other Google advisors along with the simple Google tool. So that those are very useful. Yahoo nowadays follows the similar kind of. They have updated their search engine. Previously, the Yahoo basically come with a multiple number of things, newsletter, say weather, everything come in a single page. And which some of the time it's very crazy too. Because if someone is looking to those are all data once shot, people feel crazy. When you wake up in the morning, that time your brain is in people clump, so that time always people are looking to some database which is very general and very simple. So that one is Google is following, and that one is basically the success of Google story. So then basically Yahoo nowadays updated their search engine as for the crawler and the spider-based search engine. So what are the crawler and the spider-based search engines? Crawler or a spider-based search engines mainly whenever you type a data or a word, keyword, so that time that keyword, Google basically search all over from the web page are available into the web, and then basically they combine the all word and reflect as a result into their page. Next one is the directory-based search. Directory-based search, one of the most common directory-based searches is Yahoo directory, Open Directory, and our research directory. Because our research directory is a very newest one. It comes after 2021 in the picture. Because previously Microsoft has one repository, Microsoft Academic. But that Microsoft Academic is very uncommon and people are not using that Microsoft Academic because it's they are charging some amount to access their database. But it contains a lot of articles, lot of things are there, but people are not aware of that. We are loosely aware with Google. So these directories are some of the time good, some of the time bad. If they are charging, suppose an institution has not able to pay that much of amount. So in those cases or in such cases, I would like to use some other database. So that one is basically directory-based search engines. Now come to the point of this hybrid search engines. In a hybrid search engines, this one is basically combination of product and directory-based search engines. Among them, the most popular example are Google and Yahoo. That Google, you can make a Google Drive. That one is also comes in a directory. So if you are making, suppose let's say, question or some writer, Google will share that item automatically. So you may know or unknow, you have an idea about that or not, but Google will share that. So after a few months, if you search with that term, you will get your article into Google. Another one is that meta search engine. So we suppose that someone is from chemistry side or say biology side, they are also looking to structure. Say protein crystal structure or say macromolecular crystal structure, which has the published or not. If in case of Google, you can only type, but you cannot put the picture. In the case of a meta search engine, there is an advantage. That docfile is the most common one. So if you are having a picture, that whether that molecule is published, because this one is very, very popular for organic chemistry. They are looking to that whether a particular molecule with particular active isomer, that one is published or not. Because if that one is published, they can move upon or not. Suppose another more important, suppose that histone chaperone is one important protein. So that histone chaperone, if a particular kind of crystal structure come with a full histone chaperone is published. And if I'm planning to work on the other part, before starting my work, I definitely will search whether that work has published or someone is working on it. Because if someone is taking that structure or crystal structure of that particular portion, they obviously deposit before 1 month publication in a protein data bank. Now protein data bank has the computer model structure. So one can, if one can get or identify the homology model, or say using AlphaFold, so they can deposit that structure. So in the meta search engine, one can put that structure and identify whether that result is that article or structure is published or not. So in your research, whenever you starting a problem, so before one published, one need to basically identify your problem and fill the gap, and on which part you are planning to work on. In case of a protein crystallography or say organic synthesis people, they are basically very, very familiar with this meta search engine. Now, as I had basically given us some basic common tools which one can use for search. In Google, if you are basically type one word and use that sign plus, that word or that phrase, if you are given in a single way, single shot, without any blank sign. So that plus sign means Google will search all data which are available into the World Wide Web with that particular one. So if you search with a protein blank, definitely you should give a blank sign. So protein plus DNA, All articles which will come into your first page come with protein and the DNA. The minus sign signifying that DNA data, DNA word will not be there into your data search. So plus protein minus blank minus DNA. So plus protein, your search come with the protein, whether it's a protein primary structure, secondary structure, tertiary structure, protein-protein interaction, protein hydration, everything will come without the DNA word. But if you are giving that word plus protein blank plus DNA, your search obviously will come every data which come with the protein and the DNA. So there in search, these are basically similar for every kind of search related to the plural, Yahoo or Google. So if one is giving the quotation sign, so that quotation sign will identify that particular phrase, say biomolecular hydration, say protein blank DNA. That phrase will be searched from the entire World Wide Web. If one used this sign, and then that one is this or part and. Here I have included the or part only. So this or sign, basically, if you are giving that protein or a DNA, in your first stage, protein as well as DNA will come along, and that protein and the DNA will give you similar result as like plus protein blank plus DNA. So with this just a simple plus minus colon sign and the or, one can basically update your literature. So other than to get a vast story about which you are planning, so with this couple of simple short sign, one can basically short or quench their research rather than make it unquenched. After using this one is basically very common protocol for research. That first one is a pioneering authors. So suppose I am I'm basically from the starting talking about the biomolecular hydration. So that first you have to identify that who are the pioneer author of biomolecular hydration. If you put the keyword, you can find suppose a 10 name come with the biomolecular hydration. Go to their profile. So just click on a simple article, say, example, I'm bringing one name, that John E. Straub. John E. Straub is one of the famous person in that biomolecular hydration field. So that John E. Straub, search it, with that John E. Straub, one can get multiple number of articles. So with that article, one can get a start that which kind of idea already he has published. And if that person is the repute of that particular field, then it's a very good way, rather than to make a copy with or make a derivative work of others, you can basically start with a new idea if already someone has published. Next one is the pall growing or snowballing approach. This pall growing is basically corresponds to the citation index. So every scientist has come with their own citation, as the man has already talked about in the morning, that H index and the number of citation. So if someone say first you're in your search out of using a search engine for research, first you identify the pioneering authors. Among the pioneering authors, so who are the highly cited? Then next identification will be that pall growing related to the number of citation. If someone is citing come with a very high citation, which means he is the popular one in that field with launching of new ideas and publishing work. So that is why that couple of names are very common, that science citation index, social science citation index. So those are basically, and this one is that art of humanities, arts and humanities citation index. So with those citation index, one can identify or basically extract that particular person, which is the renowned one in that field. Next one is the Google Book and Google Scholar, which are very, very common or very good search engine for the beginners who one can start. Google Books, how Google Books will help you. Google Books, if one can argue with me that Google Books is not come with a full view of all books. Some of the books are come with a snap view. Some of the books are come with a no preview. But still Google Books give you an idea about the content which is present into that book. So if that book is there and you are not able to basically hold or purchase that book, then you can look into the library. Definitely, that all books and all references are not being able to purchase a particular person because, and in such cases, that is why we are basically taking an access of the library. So that in that way, Google Books and Google Scholar can help. Next part is the importance of research. Now, in your first year, you can basically have those idea. मैंने आपके साथ बहुत कुछ शेयर किया. इसके बाद आपका जरूरत पड़ेगा literature. How basically you will get to the literature. Suppose example, you are working in a rural place and it is difficult to have an article or access an article. In such cases, you can communicate with the researcher around the world who are working in your field through research. Because to get an access of journal, it is very, very expensive. suppose say not protein and DNA, simple but taking a color. So if that one is a plus sign, you have given green. Blank. So suppose that other than the protein and DNA, I just took an example of protein and DNA. Other than that, if you are taking a color, say plus green, black plus green minus black, that means your content in the first page Google come with only the name, only that word green. No black will be there. So suppose you have started your search, say plus green, blank, plus black. So in your first page will come with green and black. Which basically sentence or which data come with that black and green, everything will come onto your first page. So if you are using that blank minus that word or any phrase, the sentence which does not contain that word or phrase which come in of the first page of Google. So that is the difference. And in another way, if you are using say green and black, give a similar instances as like plus sign when both are plus. Yes. Sorry?
Country specific. So suppose I want results from only German scientists or Italian scientists or Indian scientists, then how to search for that?
In a crawler-based search, that one is very okay. So in a crawler-based search, when I looked into only the crawler-based search, crawler-based, as I basically separated the full 4 categories. First one is crawler-based engine, second one is the directory-based, and third one is a hybrid-based. So in a hybrid-based, come with a crawler and directories. Suppose you are looking some Indian scientist, the result of some Indian scientist. That will come with the crawler-based. Simply because you have given some name of India, say if you have written some X, comma India, or say blank plus sign India, will give you the person who is working on that field from India, which you are asking. So now if you are basically looked into their work, a specific work which you are looked into, then use a search engine. That search engine will basically, your search engine, that hybrid search engine will look into the directory. Crawler-based search engine will basically look into the phrases and identify the index. If I looked into the algorithm part is whenever you are giving that word come with an index. So 1, 2, 3, 4 index item. That index will reflect in the first page of Google. So if along with crawler-based is Google, so if along with you are looking his or her word, so then use the phrases. That the phrases will basically taking from the directory which are present in the database, which database I had already mentioned, or the research database. So from that database, suppose some particular say biomolecular hydration, simple, I had used follow up with the name of a biomolecular hydration, you will get that particular Indian scientist published such and such article in Science Direct, in the other basically research directory too. So that will basically come one by one. And which phrase you have used, that will basically come with an order, ascending order.
Can you optimize the ranking?
Yes, you can optimize your ranking based on a filter. Basically, I have not, due to limitation of time, I have not discussed about the filters, but then after you will add filters. That will if you basically make it you are giving counter and immediately that counter is a more than 100, then definitely that will sound fast. Yes, my name, same with my name, one fellow is working in HR. So with my name, if I am basically clicking on my web page, some of the time my pages are coming first, some of the time my pages are coming second. But we are तो सिमिलर नाम का अगर कोई साइंटिस्ट या कोई बैठा है and he is a publishing article, then only you will feel that. Yes, definitely. Because that one is then you will add extra filter. In your Google page, you will basically have a look that there is a lot I'm feeling that. There is I'm feeling that. And then you will get a mark. Because most of the time we are not using those filters. That one is basically search engines are doing. Yes, many options. Advanced search you get many options. But some of the times
even type of article you read, whether it is CC or C, copyrighted or not copyrighted. CC also you have any type. So that also you can search the advanced.
The request is correct. All the screen detected and there are two questions from the online. Oh, designs. No. नहीं आया ना बताया क्या
बहुत फ्लक्चुएशन चल रहा है
I express my sincere gratitude to Dr. Sudhir for the wonderful talk. We surely take back valuable advice and implement it in our research. And to Dr. Sudhir, I request Professor Anshram Munshi and Dr. To extend our to open up attention.
नहीं है सर है बैकअप रखा हुआ है सर कब भी चल रहा है ऐसे है you announced
Before the commencement of the final event, we can take a small break here for lunch. I request all you to come back by. And there is an announcement for online.
1 hour 1:30 yeah.
By 1:30. Please gather here by. And this announcement for online participants. They kindly fill and submit their online feedback forms. I think. I repeat that online participants are requested to fill and submit the which has already been sent to them. welcome you back to the final. It is my pleasure to welcome you back to the final segment of the conference. The world of medical research is strongly held by the pillars of morals and ethics that also guide the path of researcher to make its way towards scientific success. It is important for us to properly understand these ethics in research. To shed light on the topic ethics in medical research, I invite Dr. Abhinav Kanwal, Assistant Professor of Department of Pharmacology, AIIMS Bathinda, to share his valuable thoughts. Dr. Kanwal is the founder faculty of the Department of Pharmacology at AIIMS Bathinda and has his interest in both clinical and preclinical studies. His research areas include those of circulant biology, diabetes and associated cardiovascular disorders, epigenetics and mitochondrial biogenesis. He is also a recipient of the S.C. Tyagi Young Faculty Award from the International Academy of Cardiovascular Sciences. It is with utmost pleasure that I invite on stage Dr. Abhinav Kanwal to share his words.
Good afternoon, everyone. First of all, thank you, Indian National Academy of Young Scientists and Central University of Punjab, AIIMS Bathinda, as organizers to invite me here. So ethics in medical research, that is the topic for today. Can anyone tell me like why we need ethics for it? Like what if we follow ethics, what it will tell about the person? Anyone? So like we are doing every day, you are working or interacting with the people, right? But we have to follow the ethics. Like you cannot abuse anyone. You have to be very polite, right? You should not be having like doing bad things with anyone, right? So why we need ethics? Like if you see this cartoon, this is a person who is like moving on the very high road, but he's happy. He is not afraid of being in that much height. Right? So ethics is like this only. If you follow the ethics, you'll be very happy and your life will be very good. If you are not following that ethics, then you are having that fear in your mind, or you maybe not be having a very good relationship with others. So ethics, we are doing practice, we are researchers, we are scientists. But what ethics tells us about it won't tell us about our profession. It will tell us about the personality of a person, whether this person is good or bad. So you also say something like, ethics follow nahi karta hai. It means person is there, but he is a good person or bad person. You are telling about on the basis of his how he follow the ethics. So ethics are from like decades or maybe from century. So Hippocrates was the first physician and he has followed some ethics and he laid down the foundation for the ethics. And they are the 4 pillars of the ethics which we are still following. First is autonomy. Autonomy is swayata, means everyone is having a right to say no or say yes. Then we are having a beneficial, means it should be in the best interest of a person. Means it should be beneficial or it should not harm others. Similarly, we are having the non-maleficence, means it should not harm any person while following these ethics. And justice, it should be fairly well to each and every person who is following this. So this is mainly focusing on identifying. What we are identifying the conditions, whether these conditions are applicable within those ethics or not. And second is, then we have to accept or not accept these conditions. The ethics are based on that, and then on the basis of these conditions, we formulate the guidelines. So Nuremberg Code is the first 12-point code, which are international codes for the ethical principles, and hence we follow these ethical principles. So can you imagine, like, why we start this guidelines? Like, we can do anything, whatever we want, right? But why we need guidelines? So just imagine there was a time when World War and pre-World War conditions were there, World War II, okay? And there were the Nazi doctors were there. These Nazi doctors, so what is happening? The Nazi pilots, they used to fly, and during the war or during their flight, they dropped their airplanes or fighter jets in the cold water. So what they used to do, these Nazi doctors take prisoners as their subjects, and they put in a very freezing temperature. They do the gunshots, and they see how long they can survive in the cold water. So that is how they start doing these experiments. So this was like very inhuman, and this was not accepted by many people around the world. And then hence the Nuremberg Code has been established, and they are given the 12 points in the So ethics are laid down by different other sub-rules, which are rules and regulations we have to follow, rules of conduct, how to conduct the thing, ethical practices, moral principles, values, and then the right principle. So that ultimately makes a big concept of ethics. So these are 12 general principles, and these are very common principles which you are following every day, or you should follow every day. The first is essentiality. You have to identify whether this particular work what you are doing is essential or not. If it is essential, go ahead. Voluntariness. It is not like jabardasti nahi karni kisi ke sath. It should be voluntary. Then non-exploitation, privacy should be there, confidentiality should be there, professional competence should be there in the right or policy manner, and then compliance should be there. So we will discuss these things later. So this is a journey of guidelines which are made with the time. The first, as I have told you, from the Nazi time, it is the Nuremberg Code, and then there was so many. It is not like one incident happened around the world. So many incidences are happening, and then there is a Helsinki Declaration. What is Helsinki Declaration? So you all know about this picture, right? So this is a thalidomide tragedy. So after taking this drug, Phocomelia or Amelia, which is like short or without any these names, the people or children are born, right? And they are survived, and they are still struggling a lot. So due to this, what is happening? Almost 2,000 children died, and 10,000 children were seriously affected. Based on that, the Declaration of Helsinki has been made by the World Medical Association, and it is accepted. It has been done on 1964, and it took 2 decades for us to understand what is the guidelines we should make for in India. So ICMR made these guidelines in 1980, first document, and they are start implementing the actual guideline in 2000. So it took almost 4 decades. So just imagine, it is not like in different parts of the world, the unethical practice happened. Even in India, these things have been happened. So there is a Institute of Cytology and Oncology Prevention. There what they did, the pregnant ladies, almost 1,100 pregnant ladies they have used as a research subjects, and they were having the cervical dysplasia. They kept those ladies without any treatment, and they want to see how much lesions it will develop with time. Out of those 1,100, 1,200 human patients, only 62 they have treated. Rest everyone they are just put without any treatment, and invasions of the cancer has been become an invasive cancer, and 50% of those has been died. So this inhuman practices has been done not outside. We can also say in our country also we are following. So looking at all these matters, we have made ethical committees, ethical, or similarly we are saying ethical review board, or in abroad we are saying institutional review board, which are IRBs. So they are having a huge role in implementing the guidelines. So I'll just give you the brief, what is the ethical committee and who should be there, and what is the role of these people. One basic medical scientist should be there, preferably the pharmacologist, clinician, legal expert person should be there, social scientist person should be there, or maybe a representative of NGO and one layman person should be there. So it is, these people have been taken from the different part of the society so that this, whatever the research is happening or whatever the guidelines you are following should be informative to the common man. And the head of this committee should be outside from the institute where this research is carried out. They should not be from the same institute to avoid the bias. So this is the committee what we are having in our aims. First is Animal Ethics Committee, and second is Institutional Ethics Committee. So what is the purpose of this committee? The purpose is any individual can approach the ethical committee. The review of proposed research before the commencement of the research. So this committee has to see this is a valid research or not valid research, whether this is a beneficial or not beneficial. To ensure the independence, the person can do this, have that independence, or timely review the ethical aspects of this research. The last part is very important. The safeguard the dignity, right, and the safety and well-being of all the actual, all benefits, potential research applicants. So it is not easy to become a head of the chairperson of this ethical committee. It is like a huge responsibility, and you have to go through each and every research proposal. So in this one, you have to see which type of human participants are there and what type of documentation you have to do. So these essential documentation should be there. And these documents, what you are making, they should be having a scientific merit and adherence to the federal regulations or IRB policies which are made by the institution or in global or in your country. So this committee has to ensure that risk to these subjects, whatever the human patients are there, or even in the animal research also, we have to see that the risk should be minimized. In patients, informed consent should be there, which is out of these 12 points from the Nuremberg Code, that the informed consent should be there. This informed consent has been implemented from the Belmont Treaty, where what they did, they put the penicillin inside the patients, and they will see how many of them are died without any taking a consent. So without taking consent, they were doing like this. So this informed consent has been started from the Belmont Treaty. And then we have to maintain the privacy and the confidentiality of the subject. So it is not like that some patient is coming and you have to open all the data about this patient. It should be very confidential. This committee has all the rights to approve, to make the amendments in the research proposals, disapprove, or even terminate this proposal. So they have all these rights. This committee also determines what is the progress you are doing during this research period. The progress they have to ensure that progress is doing or not, whether you are following this ethical regulation guidelines or not. So everything they have to do. And they also see whether you are sticking together to the institutional policies or not. So they make the policies, federal regulations, and then they also report the suspension, terminations, and even the non-compliance to the ethical committee. or to the institutional head. Then what is the responsibility of this institute? The institute also is having a huge responsibility that they have to make the guidelines, formulate the guidelines through the ethical committee. They have to educate all the these investigators. This is in contact with the clinical trials and all those. So they have to educate the investigators, scientific truthfulness, they have to see, preventing the misconduct, and they have to see whether there is a conflict of interest or not, or how this conflict of interest can be minimized or overruled. So institutions are required IRB review of the protocol and for the informed consent, administrative review of the proposals, and scientific review. So in the institutes, we are having generally two bodies. First is research cell, and second is the ethical committee. So these are the two segments which screen your proposal. The scientific review has been done by the research committee generally, and in that research committee, what they are not doing, they are not looking at the ethical part generally. So this ethical part is looking after by the ethical. So the purpose of the ethical committee is to ensure that the investigator complies with the protocol, demonstrate that they have. So generally, what you see, you have to present in front of this committee. Why you have to present? Because they have to demonstrate that the trial is necessary, or your proposal is really good, and it is a need for this R. And then they have to calculate the risk and benefit ratio in your proposal. So the IRB must review the following requirements. So whenever the proposal comes to you, you have to focus on the two important pillars of this proposal of the ethics committee. First is risks are rational and minimized. They should not be like that. Risks are more, but the benefit is very less. So it should be balanced. Second is choice of subject is equitable. It is not like only male people you have taken or only females you have taken. Okay, so it should be justifiable. Informed consents should be taken from all, and if there is a child below 18 years, then the assent form you have to take it from the parents or the guardian. Appropriate monitoring and observations should be done, because it should not be like your treatment will be put the person into a life-threatening situation. Then administrative review also you have to do. Means you are asking for some monetary benefits also, right? For to conduct the research. So in the administrative review, you have to see whether the proposal is aligned with the budget that is in compliance or not. Is there any conflict of interest within the sponsors, within the investigators, or within the institute? So if it is there, you have to take care of that also. So you have to avoid or minimize the potential conflicts which are there. This I have told you. Scientific peer review. This is generally to examine the soundness and the worth of your proposal. What is your hypothesis, whether that is a good or beneficial or not? What are the procedures you are following? It is not likely, it should not be inhuman. Okay, so it should be very less painful, and it should be within the guidelines. Whether the methods you are using are appropriate or not, or you are just making your own methods. If you are making your own method, you have to approve from the committee or ethical committee also, and from the institution. So it is unethical to expose the subjects to unnecessary risk, and sample size is also very important. So sample size is not like you would just randomly select the 300 patients I needed. Okay, or in case of animals, 300 animals I have to take. First is for the genomic study, first is for the surgery, and for the. So just imagine, like in animals also we put one sham group. Sham group means if one animal you are treating with the Alzheimer's, in the sham group you are just recreating that Alzheimer's without giving any treatment. So that is also inhuman. So So you have to see, you have to justify why you need sham group. Until unless you can use the vehicle group, right? Or if you are asking for the 20 sham groups, you just ask for the 3 subjects as a sham group. When the IRB plays the dual role of conducting the scientific review, scientifically qualified expert must be added. Means in your committee, the person one should be there who can understand what proposal you are putting, and these experts should be one first person who has read your proposal and put in front of the committee along with you. Right? So he will critically review what proposal it is there. You have to follow the DCP through clinical practices, okay, according to the International Council for the Harmonization. This is to protect the human volunteers, ensure the accuracy and reliability of the data generated in the course of the clinical trials. So the compliance with these standards, the public pledge that the rights, safety, and well-being of clinical trial participants will be protected. So just imagine, you are here in this conference or workshop, okay? We will tell you, we will give you 5,000 rupees to come in this conference. The number, what right now is there, it will become 4 times or 5 times, right? Definitely. Why? Similarly, this is happening here. So there is a monetary benefits to the volunteers also in the clinical trial. Okay. So you have to take care of that volunteer, human volunteer, that they should not feel, they should not be exploited. Even they are coming, it should not be that we are putting them into the life-threatening conditions. So it should be compliant with these standards and guidelines, and there will be a safety of their rights as well as their well-being also. Good clinical practice covers obtaining informed consent. So you have to take informed consent from every volunteer who is participate in that research. Documentation should be there, and reporting should be there. So these 3 are very, very important aspects of any research. Similarly, like even in the animal studies that we do, we keep this data for the next 10 years. Why? Because they can ask anytime. Then ethical issues are also there with the design of the study. So it is not like you can choose whatever you want. You have to justify why you want this many numbers of patients or animals. Or you have to do randomization, blinding, or the problem of the placebos are also there. So you have to use standard medications or placebos you have to use. Then you have to also identify what is the whole risk and benefit after doing this randomization, placebo use, whether it is useful or not. So RCTs are the randomized controlled clinical trials or controlled trials. These are the studies which randomizes your sample. And then whether these participants are given treatment or placebo, it is randomized whether they have to give placebo treatment or your treatment test drug. Yeah. So this is for the clinical equippers, means it should not be biased. It is not like you can give anything to whatever you want. You have to do the blindness also. So whether it is blinded to the physician or it is blinded to the patient, like what type of drug you are taking, because there is a psychological results are also added in that. FDA generally approved RCTs. They are saying this is one of the best methods to avoid any type of bias. The RCTs are ethically permissible using the standard clinical equipoise in the context of non-life-threatening therapy. But serious problems remain, however, in clinical equipoise that can be easily upset. So, if you are having a system where someone knows what type of drug you're giving to whom, so you can disturb whole trial. That single person can become biasness, show the biasness, and then they can do or waste all your research. So branding is very important. So we are having single branding, double branding, triple branding. So single branding means the patient doesn't know what he is taking, either the test drug or the placebo is taking. Double branding means physician also doesn't know what he is giving. Third is even the sponsor and investigators who are giving this, they also don't know what type of drug they are giving. Or so this is to avoid any type of bias. Then is the placebos. Placebos are very, very important in research, and you have to clearly demonstrate why you need placebo. So there are two things are there, placebos, or you have to compare with the actual well-defined treatment. Suppose you are doing any study on the painkiller, and you know that diclofenac is the first, which is a standard drug you have to give. So you have to test your test drug with the diclofenac. It's not so the first treatment you have can be compared with the placebo, but not with the diclofenac. But if there is a standard treatment already available that you know this is the standard drug, so you have to compare with the your standard drug only. But in this case, diclofenac. So placebo controls are intended to ascertain the authentic effectiveness of the treatment. So if you give the placebo, you will understand whether your treatment is good or bad, but it's not comparing with the standard treatment. So there's a difference between the placebo treatment and the standard drug treatment. So it also eliminates the various disturbing factors and determines the actual therapeutic efficacy of the new treatment. So if researchers wish to test a new treatment in the absence of non-effective treatment, the use of placebo is problematic and unethical. Means if standard drug treatment is there, you cannot use placebo. If you're using placebo, it means you are biased towards your study. Then the main purpose, ethics generally is very much needed in case of the phase 1 clinical trial. Here we are looking at the level of the toxicity of the drug and what is the efficacy of that particular drug what we are having. So these two things we are finding. And this is the stage whether it will tell your molecule or the new chemical entity will go to the next stage or not. So you are having a huge investment here, huge time you are invested as well as the money. So many people, if not following ethics, is this main study that is called the phase 1 trials. This is to determine the highest tolerated dose, which is the below the EC50, what we say. Then effective dose or ED50, effective dose 50. After determining the lethal dose 50 of a new drug. And human studies bring about much tension and conflict between the goals of science, those of clinical care, bringing special challenges to the IRB. So for the IRB, this is the main challenge, how to avoid these type of issues. So we check the level of toxicity and pharmacology. So sometimes it's very difficult for the sponsors to become ethically loyal in the phase 1. Phase 1 is very crucial. So even in the participant recruitment, it is not easy. Sometimes you become biased that you are taking only females or you are taking only osteoarthritis patients. So this type of things should not be done, and it should be justified in front of the ethical committee. Informed consent. I'll just give you the 3 key components in the informed consent. It should be there. First is information. Whatever you are doing in your proposal, you have to inform to the participant. And the participant should be a volunteer participant. Second, it should be understanding by him. He or she should understand what you are saying, what you have written in your proposal. Means, if a person is from a Punjabi community, and this is happening somewhere in the Telugu community, then you have to tell that consent form in the Punjabi language. So the language should be a same language, but the volunteer is there. So you have to tell, it should be very understandable. Second is, it should be volunteer agreement. It should be signed that he is taking participate in this study. If it's a child, then it should be given by the parent or the guardian. So this is the patient consent form what we are using in our aims. So this is all we are telling about the nature and purpose of the study, duration of the participation, procedure what we are following, investigations what we are following, and what is benefit to the volunteer in this by this study. So this is just the activity, whether you are understand what I have told right now or not. So there is a 2 graduate students, and they have made the measurements on the new material. And this is the graph that we have, they have got it. So in this graph, these 2 points are the outliers. Okay, so the 2 students considered omitting the 2 data. And he has omitted these 2 points to make the very good this graph. So whether this is ethical or non-ethical. You have a very good data. See, this data is very good. And if you find out the regression value from this, it is 99.9%. For sure, because most of the data is coming on the line. But only 2 outliers out of this that you can remove also. Hardly matters. Because already you got a very good data, right? So you can remove these 2 data, right? No. You cannot remove this data. Rather than you have to give the justification why this data, because it hardly matters your results are good. If your results are not good, you have to repeat the experiment. Simple. In any experiment, you are repeating 3 times, right? Why we are doing this? Because you have to see the reproducibility of that. So maybe this is a mistake. You can do second time if you are not satisfied. This is unethical. Second is students are required to prepare research proposal during their undergrad program. And there is a student named is Nirmal, developed the idea for his project and discussed with his friends. Several months later, he found that this idea had been submitted as a research proposal by his friend without his technology. Unethical. So what we should do? What should we do? This one is very simple, right? So if you are having It is a plagiarism, but what he should do then? It's definitely plagiarism because he has taken the idea from it. So he should discuss with him and put him as a co-author, or give the equal partnership within the paper. Right? If he is not agree, then he should revoke it. Then he should revoke it. Okay. Because it's not published yet, right? Then 4 friends decided to work together on a research project during the vacation, and one of them is not attending. He's roaming here. The friends include all 4 names in the presentation made at a scientific conference. So one person is not there, but they 4 have decided. But one person is not taking, he is just haven't any contribution. So what should we do? We do all these things, right? If we put names of every person in our paper. It's a very common practice. And here there is common practice. What should we do? It's unnecessary. So ethics is not you are a good by profession. Ethics tells us about the personality of it. You are in your home, someone say, आपके पड़ोसी भी बोलते हैं ये अच्छा है ये बुरा है किसके बेसिस पे? Only on the basis of ethics. A group of undergrad students planned a research project on the detection of a fetal abnormality in the second trimester and by ultrasound scanning. They collected the data from the scan room without informing the mother. Unethical, but it doesn't matter, right? It's only scan. So the group of undergrad students planned a research on detection of fetal abnormalities by taking the UGC ultrasound. And they collected the data from the scan room without informing the mother. So the patient, they are not telling, but they have taken the data. Because we are having so much data, I have taken the data and from the user scan and published it. Unethical, right? It doesn't matter whether this is beneficial or harmful to the mother, but the data belongs to her. It's a controversial, so you should not do it. Thank you. This is some. Thank you.
Now it's open for discussion. If you have any other query.
Anyone wants to ask anything? So that is the differentiation. This is a very thin line between the good and bad, right? Ethics and unethical.
What is the basic difference between non-malefacient and beneficial?
So non-malefacient means it should not harm anyone. Beneficial means it should benefit to anyone. So there is one person with a neutral. If suppose I am here, you are not saying anything bad to me. I'm good, right? You are not doing any harm. So there is harm and benefit. Okay, so something you are having to eat, to offer me to eat. If you are not giving me, I'm good. If you are taking anything from me, it's a harm. If you are giving to me, it's still benefit. But if you are not doing, I'm neutral. That's the thing. Anyone else?
Online में question.
हाँ, बोला है. Still it's not yet raised. अभी तक आया नहीं.
Question. Okay.
आया नहीं.
Thank you. Thanks.
Thank you, Dr. Abhinav Kanwal, for such a wonderful speech. I'm sure everyone will be
Just now,
will
just
take
now,
back the
receive one
validated
question.
guidelines and learn something from it. May I have the good fortune of inviting the members of the organizing committee to felicitate Dr. Abhinav Kanwal for giving a speech.
Question is,
If we
है मैम
Today's world of science revolves around data and its implications in research. No research is quite complete without the involvement of data in it. It is hence important that we understand the efficient analysis and interpretation of this data. To elucidate on the topic, data analysis, interpretation, and presentation, join me in welcoming Dr. Madhur Verma, Assistant Professor of the Department of Community and Family Medicine at AIIMS, Bhatinda. Dr. Verma has done his work on non-communicable diseases like obesity and has focused on health system research. He also specializes in health informatics and secondary data analysis. With approximately 68 articles published in national and international journals, Dr. Madhur is currently working on the geospatial analysis of infectious diseases and other disorders such as obesity, hypertension, and diabetes. I invite Dr. Madhur Verma to come to the stage and share his words of wisdom. Please welcome him with a big round of applause.
Hello everyone. So thank you to the University of Punjab and India for considering me for this lecture. Though it is a very vast topic, but we'll try to cover some, basic aspects regarding data.
So, so before I start my presentation, मैं ये रख लूं? पीछे बोल रहा है। मेरी आवाज आ रही है आप तक? So before I start my presentation, I would just like to have a brief background of the audience we are having here. So how many of you are undergraduate, postgraduates and PhDs at this moment and currently having any kind of thesis or dissertation to submit? So I just wanted to know how many of you do have a current project of thesis or a dissertation to submit. So how are you planning? Thank you very much. So how are you guys planning to do your analysis? Your protocols are prepared. I'll try to make it more interactive. So please come with me. So how many of you have prepared your protocols and you have a complete data analysis plan ready before data collection? No. So I think this was the mistake that I made when I submitted my thesis, and by the end I collected my data. I was not having a clue of how to analyze that data. So when I went to Safdarjung Hospital, New Delhi, as my senior residency, so there I saw this practice that once they have completed their protocols, they have a by the end of the other year, they have to submit a data analysis protocol. The initial protocol will be talking about your research topic, your key aims and objectives, and your expected outcomes by the end of the study. Whereas the data analysis protocol, it will talk about how are you planning to collect your data and how are you planning to present it. So this is the main one thing that I learned there. So I would like to share it with you. So what happens is when we are collecting our data, if we are not having a clue about how are we going to present this data, so at the end, data may look very messy. And you can all see that you come up there. So data is always very problematic if you do not know how to handle it. So either you know from the beginning how you're going to handle your data, or at the end you are going to follow all the protocols that Dr. Abhinav has told us just now to get effective results. Because we all in this society, we are not very prone to negative reports and non-significant findings. And if it is a general assumption that if it is a thesis, then the results have to be significant. At least in my medical science, but we have seen, if we are having results that are not very significant and not very, they do not look very good and have a good p-value of, then they are not very welcome in most of the journals, in many journals. But now the things are changing because negative findings are also good findings. We have already seen this during the COVID times. We were running a lot of RCTs, we were trying new drugs, we were trying new therapeutics, and not everything was proving to be good or beneficial for the patients. So if you are reporting negative findings, non-significant findings, but also following a robust protocol, then these findings will be welcome, because now the other scientists around the world will not be utilizing their time, their resources in doing the same, repeating the same experiment. But at the end, you should be, what you are reporting, it should be very robust. So once we have collected our data, if it is not properly planned, then we land up having an unstructured data set. And then it is a pain in itself. Apart from all the thesis analysis, everything, managing your data can be breathtaking, and it can just consume maximum of your time. So it is mostly reported, the incorrect data is because you do not have the understanding of how to manage your data, and it should be like there is always incorrect labeling. Sometimes you are writing male as MALE, sometimes you are using uppercase, sometimes you are using the lowercase, sometimes you are just using M, sometimes you are just using the F. So there is inconsistency in entering your data. Then if you have used wrong codes, coding will definitely save your time. But if it is not correctly coded, then the results may vary badly. Like for example, last year we were doing certain data analysis where the missing data was reported as 9999. This is what is a usual way of reporting missing data. But once I was trying to calculate my mean, and we had not omitted that 9999, my means were significantly affected. You can all understand that. If say for example, I have 10 people who are in between the age of 14 to 18 years, so my mean should be approximately between 14, 15 or something, whatever the age may be. But if you are reporting your mean value, missing value is 9999, and then you take the mean without excluding those missing cases, then your results will not be the accurate estimates. So what we can do is, we have to take care of this coding, the spacing, even an extra space. Computer consider it as a command. An extra space can change your output. Duplication of the data, the multiple responses, these are all things that can cause you pain during the time of analysis. So this is one untimely data. If you can see this, is it visible to you? The last one. Can you tell me if we have some problem in this data? Tell me the clause. आपको लगता है ये डेटा एनालाइज करना आसान होगा? कुछ गलतियां बताइए प्लीज. Anybody can answer. हाँ.
For example, like in day,
हाँ.
fourth entry it should be 05. If other are also like
Day.
what is it? Day.
Yo,
For
okay.
week two, it should be 05.
Okay. Fine. और कुछ?
So in the lower one, the cap, like if everything is written with a capital W, and then suddenly having small.
Okay. Fine. Anything else, please? Missing rows. Very good. Because the patient is same. Because the patient is same, so the author has preferred not to enter the same field. What I can see is they have mentioned age and gender at the same place. So if you are going to analyze this data, how is the computer going to read this? Computer is going to consider it as 3/ and an F. So if you want to generate your mean values of the age, what kind of patient population you have. So this would not be possible here. And say for example, at this moment, the sample size is only 20. But let's say we have a sample of 20,000. So disaggregating this data can be very time consuming. Okay. So we have to take care from the very beginning before starting to enter our data. Then we can see this, the visual acuity part. They have written it as 6/18. Ideally, it should be, because ideally it should be, the denominator should be in a separate column, the numerator should be in a separate column, and then we can derive a new variable if you want to have an analysis. Then, and this is not a very preferred way of entering your data. Here, the scientist has entered day-wise data in the rows. Ideally, it should have been done as in columns. Similarly for the other line. Now this is also very untidy data. If you have a good case report where you have collected your case sheet, where you have collected your data, then we do not need to write the name, the CR number, the IP number. It should not be of much importance to you. If you can, what I did is I simply gave it a code 1, and then started writing my data sheet, entering my data. It saves you a lot of time. But it is the treatment for, say for example, here the treatment for pemphigus. It is kind of a dermatological illness. Here they have mentioned all the medicines at in the same cell. It will be very difficult when we are going to analyze this. Say for example, I want to see how many people are actually on Bisonon, how many of them are having azathioprine, how many of them are having rituximab. If we consider, the computer will consider these 4 drugs as one entity, and you will not be able to generate good result. So there are 4 fundamental ingredients of structured data. The rectangular array. The data should be properly, the data should be entered in the rows, while the data, the variables for which the data is entered, it should be in the columns. This is the usual format that we follow. And this is also the most easiest one. The variable. What kind of data you are going to collect? It is a variable. Variable can be a dependent variable or an independent variable. Then measurements. Weight can be written as 1.5 kgs, 1500 grams, or beyond that. Okay. It is all the same. But once we are analyzing this, if the units are not same, then we are going to have different results. Say for example, 2 people are having weight of 60 kgs. For one, I write it 60. For other, I write 60,000. Both the weights are equal, but it was one is grams, one is kilograms. And once I am calculating my mean, the results will be very different. And then the cell. Each cell should have one information. Ideally, each cell should have one information. Like the slide there where we were talking about the treatment, one cell was having more than one information. He was having steroid, he was having the immunosuppressants. Okay, so this is a very good example of a structured data set. What we have done, what I would request you all is to the one take-home message for your whoever is writing your thesis. Before entering your data set, you should have a data entry sheet, protocol, where you will always mention what kind of data that you are going to collect, what should be the description of that data, how you are going to code it, and what will be your measurement scale. Because you may not be the only one who is analyzing this data. There may be other people in your team. As you grow as a scientist, you will have many people under you who will be analyzing, helping you in your analysis and everything. So one person may not be able to handle everything, so they'll be sharing it with other people. And if you do not have an analysis plan, then they'll be doing at their own games and fancies. So I may consider it as a string variable. I may consider it as a interval or a nominal variable. Okay. So this is the one good thing. Also, if you use the codes, it will save lot of time for your data entry. What I prefer is every day when I'm trying to enter some data for the study, we make a Google form, and I specifically mark the compulsory options for each and every cell. So data entry is very easy because you are not running into different rows and columns. For each person, you can have your data, and here in that Google form, you can use drop-down menus. It will save your time. And now also, you will not face the problem of having इनकम्प्लीट आउटलायर्स। फॉर एग्जाम्पल हम बात करते करते 1 की जगह 1 2 बार टैप कर दिया, ए को कैप्स लॉक बंद हो गया, कभी कैप्स लॉक ऑन हो गया। तो जब आप आउटपुट करेंगे तो वो छोटे ए को 1 यूनिट लेगा और बड़े ए को दूसरा यूनिट लेगा। तो अगर गूगल फॉर्म कर देंगे आप, तो उसमें आप ये कोड लगा देंगे कि इसमें सिर्फ अपर केस में ही डेटा एंटर होगा, तो वो चीजें यूनिफॉर्म रहेंगी। उसको आप इजीली कहीं पे भी बैठ के एंट्री कर सकते हैं। यू डू नॉट नीड टू हैव अ लैपटॉप एवरी टाइम। आप यहाँ भी खाली बैठे हैं, आपने डेटा एंट्री करा, डेटा कलेक्शन करा, फील्ड से आते आते ही आप अपने फॉर्म भर सकते हैं। तो यू विल हैव मोर डेटा दैट इज आल्सो सेव्ड इन क्लाउड्स। आल्सो विद इन दिस कंटेक्स्ट मैं पूछूंगा कि आप लोग अपनी फाइल्स को कैसे मैनेज करते हैं, किसी फाइल्स को। पीएचडी वाला कोई कैंडिडेट बताए प्लीज, पीएचडी कोई है? हाँ जी जी मैम, डॉक्टर साहब बताइए कैसे करते हैं आप अपने फाइल्स को मैनेज। फाइल्स इन एज इन द प्रोटोकॉल्स, द थीसिस ड्राफ्ट, द डेटा। हाँ चैप्टर्स होते हैं आपके, आप उसको कैसे सेफगार्ड करते हैं और कैसे कैसे याद रखते हैं विच इज द लेटेस्ट वर्जन। मेरे तो एमडी के दोस्त थे, वो आखिरी दिन आते थे थीसिस सबमिशन से पहले, मेरे को मेरी फाइल नहीं मिल रही, उनके लैपटॉप में है, उनके लैपटॉप में है, उनको फाइल नहीं मिल रही है ना। मेरा एक्सेल शीट करप्ट हो गया।
फाइल नेम दे देते हैं, उसमें ही इसके आगे पार्ट्स बन जाते हैं।
मैं जब एमडी कर रहा था तो मैं हर फाइल को फाइनल फाइल देता था, मैं फाइनल
फाइनल
तो मैंने क्या सीखा जब मैं पीजीआई में था, तो मैंने वहाँ पे क्या सीखा, मेरे प्रोफेसर ने मेरे को डांटा, डू नॉट राइट फाइनल। वो मेरे से 20 रिवीजन करवाते थे एक मैन्युस्क्रिप्ट की, तो मैं उनको फाइनल लिख के भेजता था, तो सुबह सुबह मेरे को पहले उसी चीज की गाली पड़ती थी, फाइनल कैसे लिख दिया तुमने अभी, जब मैं बताऊंगी फाइनल तब फाइनल होगा। तो उसमें हमने क्या करना शुरू किया कि मैन्युस्क्रिप्ट का नाम जो आपका काम चल रहा है, अगर ये थीसिस की इंट्रोडक्शन है, इंट्रोडक्शन अंडरस्कोर आज की डेट, ठीक है 29 आज 3 तारीख हो गई, 03/12/2022 अंडरस्कोर MD, ये मैंने बनाई थी और मधुर वर्मा ने बनाई थी। नाउ विल आई सेंड इट टू माय प्रोफेसर, वो देखेंगी, अगर उन्होंने उसमें कुछ चेंजेस करे हैं तो वो को MD की जगह MG कर देंगे उसी दिन को, और टाइम एंड डेट जो सेव किया आपने वो आप वहां पे रख सकते हैं, ठीक है। फिर दूसरा प्रॉब्लम क्या आती है, डेटा आपने सेव कहाँ पे किया। जैसे मेरे लोग जो बोलते थे कि हमारी तो फाइल उड़ गई, अब क्या करें। मैं उस समय, तब हमारे पास गूगल ड्राइव नहीं होती थी, ड्रॉप बॉक्स नहीं होता था, तो हम लोग रेगुलरली अपने आप को मेल कर देते थे, अपने आप को ही मेल करते रहते थे। हाँ, तो दिस इज वन गुड थिंग दैट आई लर्न। उसके बाद लैपटॉप क्रैश होने तो कम हो गए। मैं रात को गेम खेल रहा हूँ, वो गर्म हो गया, क्रैश हो गया, और सुबह थीसिस दिखा दी, तो वो ऐसे बहुत बार ही हुआ, तो मैंने बहुत डांट खाई है। तो फिर अब गूगल ड्राइव आ गई है आपके पास, यू कैन हैव एवरीथिंग इन योर क्लाउड, और ईमेल करना सबसे सेफ और इजीएस्ट ऑप्शन। मतलब डेटा हैकिंग कभी भी हो सकती है, कभी भी, इतने बड़े लेवल पे हम फ्लॉ कम एक्सपेक्ट करते हैं। और अगर आपको फिर भी ये सब कुछ नहीं चाहिए, आपको किसी से शेयर भी नहीं करना, एक पेन ड्राइव रख लो अपनी, वो पेन ड्राइव आप किसी से कभी शेयर नहीं करोगे, और ज्यादा क्लीन करना है तो एक CD बना के रख लो, ठीक है, व्हाटएवर यू वांट टू डू, बट ट्राई टू कीप इट सेफ। रेगुलर यूज के लिए डेटा मैनेजमेंट कैसे करता हूं मैं, कि मैं अपना एक व्हाट्सएप ग्रुप बनाया, उसमें पापा को ऐड किया, फिर उनको निकाल दिया, फिर एक ग्रुप बन गया जिसमें सिर्फ मैं हूँ, और मैं जो भी इंफॉर्मेशन शेयर करनी होती है वो मैं उस ग्रुप में डाल देता हूँ। वो किसी के पास नहीं जाती, पर वो मेरे पास हमेशा है, और मेरे पास हमेशा उसका बैकअप भी रहता है, ठीक है सर। तो मेरे सारे पासपोर्ट, आधार कार्ड वगैरह वगैरह हम उसमें रखते हैं। तो दिस इज हाउ आई हैव लर्न टू मैनेज माय डेटा, बिकॉज इवेंचुअली यू विल हैव अ लॉट ऑफ स्टफ टू स्टोर एंड यू विल नॉट बी एबल टू ट्रैक एवरीथिंग, so you will have to follow these rules to manage your data. So ji, coming on to data analysis, the correct selection of statistical tests depends on the knowledge of 5 fundamental ingredients. बोर हो गए? ये ऐसी क्लास होती है. So, what is the type of outcome variable? आपका जो outcome variable है, वो किस तरह का होगा? कुछ बताएंगे कैसा हो सकता है? What can be your outcome variable? It can be a number, it can be a rate, it can be a ratio, it can be just a nominal variable, it can be an ordinal variable, है ना? मैं पेशेंट का अनीमिया देख रहा हूँ, आउटकम कैसा था? अनीमिया प्रेजेंट और एब्सेंट, yes or no? अनीमिया माइल्ड, मॉडरेट और सीवियर. Anemia, not anemia, but hemoglobin values less than 7, more than 7. So this is going to be your outcome variables. Then we have predictor variables. Predictor variables मतलब जैसे अभी मैं कोई स्टडी करना चाह रहा हूँ कि what is the effect of physical activity on having heart attacks in next 10 years. So outcome is the risk of having a heart attack. कैटेगरी इसका हो गया ऑर्डिनल में आउटकम 1 2 3 4. नो रिस्क, मिनिमम रिस्क, मॉडरेट रिस्क, वेरी हाई रिस्क. दिस इज द आउटकम वेरिएबल. प्रेडिक्टर वेरिएबल इज फिजिकल एक्टिविटी. इट कैन बी आर यू फिजिकली एक्टिव, yes or no, or if you have collected in a better way, I have collected the metabolic equivalents, so I'll be having the predictor variable is continuous. Number of days you walk, it is also what kind of data is this? Number of days are increasing, so it is a ordinal data, and so on. And then number of groups. How many groups you are going to have at the end? आपके पास जो comparison group है, placebo group है, group medicine group 1, then a placebo group. You can also compare it with the third group. जैसा अभी कोविड के टाइम पे आपने देखा इतने RCTs में everything was being compared to placebo or the standard treatment options available. And the type of study design. Type of study design क्यों important होता है? अगर आपको associations और causations को prove करना है, तो आपको study design ध्यान में रखना पड़ेगा. क्रॉस सेक्शनल स्टडी में आपने एक क्लास में देखा इस समय कितने बच्चों को नींद आ रही है, ठीक है, और वो नींद इसी लेक्चर के कारण आ रही है कि नहीं आ रही, ठीक है. तो अब मैंने क्या देखा, इस समय मैंने आप लोगों से बात कर ली, कितनों नींद आ रही है, तो उन लोगों ने हाथ खड़ा कर दिया. मैंने देख लिया 25% पीपल आर फीलिंग स्लीपी. तो या तो, और क्लास चल रही है डेटा एनालिसिस की, तो अभी क्या बात हुई कि 25% of the people were feeling sleepy in the class of data analysis. So, is data analysis sleep producing? Sleep inducing. Thank you, madam, for correcting my words. So, I can only associate things, but I cannot prove things with the cross-sectional data. Okay? इसको अगर प्रूव करना है तो कैसे प्रूव करेंगे आप? जी, रोज ही अगर 2 से 3 के लेक्चर में आ रही है तो इट इज नॉट माय लेक्चर ओनली, ये आपके रात में चावल का कमाल है, ठीक है. तो हियर वी विल हैव here we need a different study design, and just to make associations we will have a cross sectional study design. लास्ट बेंच वालों को समझ आ रही है? हाँ जी, थैंक यू. आपने बढ़िया नाम खिलाया सबको. एंड देन वैलिडिटी ऑफ assumptions. वैलिडिटी ऑफ assumptions एनालिसिस करने से पहले हम बेसिक माइंडसेट लेके चलते हैं कि एवरीथिंग इज नॉर्मल. तो assumption अगर मैं स्टडी करना चाह रहा हूँ तो मैं ये एज्यूम करके चल रहा हूँ कि आई विल बी हैविंग पीपल फ्रॉम every domain, every characteristics. Say for example, I want to know what is the prevalence of physical activity in general population. What is the level of physical activity in general population? Okay. So what I am going to do is, इसके लिए क्या करना पड़ेगा मेरे को? अगर मैं अपना सैंपल स्टूडेंट्स में से ले लूं, सारे लेट ही होते हैं, सब रात को लेट सोते हैं, जिन कोई कोई जा पाता है, कोई कोई नहीं जा पाता, So my results will not be generalizable. I cannot make inferences because my sample selection was not appropriate. So what I can do is कि मैं अगर आप लोगों का डेटा ले रहा हूं, I can only make descriptive results. So this जब आपने एक सब सैंपल से एनालिसिस किया, तो this is descriptive statistics. And when you are able to make estimates for the population, then it is inferential statistics. Okay. तो इसमें हम assumption लेके चलते हैं कि अगर आपकी सैम्पलिंग मेथोडोलॉजी ठीक है, so our sample will be having a normal distribution curve. कि जनरल पब्लिक में हमने देखा है कि कुछ लोग ऐसे हैं जो रेगुलरली एक्सरसाइज करेंगे, कुछ लोग ऐसे हैं जो बिल्कुल भी नहीं करेंगे, और कुछ लोग ऐसे हैं जिनका कभी मन किया तो कर लेंगे, जिनको कोई जलील करेगा तो वो कर लेंगे, नहीं तो नहीं करेंगे, है ना? तो दिस इज द थर्ड कैटेगरी इज द मोस्ट कॉमन कैटेगरी. So we will have this is the middle. या फिर कपड़े टाइट हो जाएंगे. तो जो ये वाला ग्रुप है ये आपका बीच में आया. This will be having the maximum population. जो रोज एक्सरसाइज करेंगे वो थोड़ा सा साइड में आ जाएंगे, और जो बिल्कुल नहीं करेंगे वो दूसरी साइड में आ जाएंगे. इन टोटल वी विल हैव अ नॉर्मल कर्व, क्योंकि नेचर का रूल है ना ये. लड़के लड़कियां जो भगवान पैदा करता है वो कोई उनको बताता तो नहीं कि 50 लड़कियां हो गई हैं, 50 लड़कों की बारी है, ऐसा तो नहीं है. एवरीथिंग इज ऑन इट्स ओन. ठीक है. तो ये इट इज अ नॉर्मल कर्व. बाय रूल गॉड हैज मेड एवरीथिंग नॉर्मल. जो 4 उंगलियां हमारी सब एक जैसी नहीं है, पर एक सबसे बड़ी और बाकी 2 छोटी छोटी, है ना? क्लास में भी ओबीस बच्चे भी होंगे, पतले बच्चे भी होंगे, और नॉर्मल ओबेसिटी के बच्चे भी होंगे, है ना? दिस इज बाय नॉर्मल. दिस इज द नॉर्मल assumption. तो जब हम अपने रिजल्ट्स को एनालाइज कर रहे हैं तो हमें ये एज्यूम करना है, हमें ये assumptions को लेके चलना है. और 3 सबसे बढ़िया assumptions जो आप लेके चलते हैं वो कौन सी होती हैं? नॉर्मैलिटी, लिनियरिटी और वेरिएशन. ठीक है. तो इसके बारे में अगर हम भी बात करें तो अभी हमारे पास आया पैरामीट्रिक टेस्ट एंड नॉन पैरामीट्रिक टेस्ट. पैरामीट्रिक टेस्ट कौन से होते हैं? विच वर्क्स ऑन अ नॉर्मली डिस्ट्रीब्यूटेड पॉपुलेशन. जैसे कि अभी मैं कम्युनिटी में जाऊंगा, गांव में जाके फिजिकल एक्टिविटी देखूंगा, वहां पे हमारे पास नॉर्मली डिस्ट्रीब्यूटेड पॉपुलेशन होगी. वहां पे जो मैं रिजल्ट लगाऊंगा दे विल बी नॉर्मली डिस्ट्रीब्यूटेड, जो आउटपुट निकल के आए. ठीक है. अगर इस वाले ग्रुप में लगाऊंगा, आप एक जैसा कोहॉर्ट हो, सबकी क्लासेस बराबर टाइम पे, सबको उतना ही पढ़ाई करनी है ना, तो हमारा जो डेटा है वो स्क्यूड है. ठीक है. और ये सैंपल जो है इट इज नॉट रिप्रेजेंटेटिव ऑफ द होल पॉपुलेशन. तो यहाँ पे मेरे को नॉन पैरामीट्रिक टेस्ट लगा के. ठीक है जी. अब पैरामीट्रिक टेस्ट में हम वेरिएंस को एज्यूम करते हैं कि इट इज होमोजेनियस. वेरिएंस का मतलब क्या हुआ? आपका डेटा कितना स्प्रेड आउट है. ठीक है. अब अगर वही फिजिकल एक्टिविटी में ऐसे गांव में करूं जहां पे 10-12 पहलवान रहते हैं, ठीक है, जैसे हरियाणा के रेगुलरली गांव में होता है ना, कि वहां पे पहलवानी रेगुलरली होती है, तो वहां पे जो वेरिएशन है फिजिकल एक्टिविटी में, वहां पे एक बाबा जी भी हैं जो सारा दिन बैठ के हुक्का पी रहे हैं, और एक दूसरे पहलवान है जो दिन में 2 घंटे 3 घंटे कुश्ती कर रहा है. तो दोनों की फिजिकल एक्टिविटी में बहुत ज्यादा वेरिएशन है. Here the data is quite spread out. और इस स्प्रेड आउट को आप कैसे कम कर सकते हो? अगर इसमें मैं सैंपल लेके चलूं अपना 10 लोगों का, मान लो 10 लोगों का सैंपल लेके चलूं, तो आपके पास अभी कैसा डेटा आया? एक बाबा जी, कुछ लोग, और यहाँ पे एक पहलवान. ठीक है. तो डेटा बहुत ज्यादा फैला हुआ दिखेगा आपको. अब इस 10 लोगों में और 10 लोग ऐड कर दूं, तो अब बाबा जी के साथ कंपनी देने वाले और लोग आ गए, पहलवान के साथ और लोग आ गए. कुछ ऐसे लोग हैं जो पहलवानी सोच रहे हैं, कुछ ऐसे लोग हैं जो पहलवानी छोड़ चुके हैं. तो उनकी जो कर्व है वो धीरे धीरे नॉर्मलिटी की तरफ बढ़ता जा रहा है. तो जैसे जैसे आप अपना सैंपल को इंक्रीज करते जाएंगे, वैसे वैसे यू विल रीच नॉर्मलिटी, अ नॉर्मल कर्व. ठीक है. पर ये नॉर्मल कर्व आप हमेशा करना मुश्किल होता है, क्योंकि इसमें कॉस्ट है। अगर हम सारी पॉपुलेशन का ही ले लें, सबको ही लेना पड़े अपने सैंपल को नॉर्मल करने के लिए, तो हम सैंपल पे क्यों करें, हम सारी पॉपुलेशन पे करें, है ना। आइडियली तो यही देखना है, आपको देखना है कि इस गांव की फिजिकल एक्टिविटी लेवल कितना है। तो आप क्या देखोगे, सारे गांव को बुला लो एक एक करके, उनके फिजिकल एक्टिविटी लेवल देख लो, फिर आप मीन वैल्यू दे दो, और उसमें कितना टाइम और एनर्जी लगेगा, पैसा कितना लगेगा। अभी तो मैं सिर्फ बात करने की कर रहा हूँ, विटामिन डी लेवल देखने हैं आपको, ठीक है, उनका थायराइड लेवल देखना है आपको। तो सारे गांव का करोगे तो लाखों रुपए लग जाएगा। तो आप क्या करोगे, एक रिप्रेजेंटेटिव सैंपल लोगे जो कि जिसमें हर डोमेन से, हर स्टेटा से लोग अपने अपने सैंपल में इकट्ठा करें, और उससे आप अपने रिजल्ट निकालोगे, ठीक है। तो दो बातें हो गई, एक तो होमोजेनिटी, नॉर्मल एज्यूम्ड डिस्ट्रीब्यूशन, देन इसमें जो आपका पैरामीट्रिक टेस्ट होते हैं, मोस्टली इसमें जो डेटा होता है वो आपका इन रेशियोज और इंटरवल की फॉर्म में होता है, जबकि नॉन पैरामीट्रिक में डेटा आपका ऑर्डिनल की फॉर्म में होगा, नॉमिनल की फॉर्म में होगा। और डेटा सेट रिलेशनशिप्स, वन डेटा इज नॉट रिलेटेड टू द अदर डेटा। डेटा इंडिपेंडेंसी इज वेरी गुड assumption, वेरी इंपॉर्टेंट assumption जो हमको साथ लेके चलनी है, ठीक है। अब जैसे मैं फिजिकल एक्टिविटी को ही देख रहा हूँ कि फिजिकल एक्टिविटी और प्रोटीन इंटेक, मान लो ऑब्वियसली जो बंदा जो फिजिकल एक्टिविटी ज्यादा कर रहा है वो प्रोटीन भी ज्यादा ले रहा होगा, क्योंकि उसको अपनी सेहत का ध्यान रखना है। से फॉर एग्जांपल मैं नॉर्मली ये नॉर्मल एजम्पशन लेकर चलता हूँ, तो उसमें दोनों डेटा आपस में रिलेटेड हैं, वन डेटा इज रिलेटेड टू द अदर डेटा। तो डेटा इंडिपेंडेंसी यहाँ पे प्रॉब्लम आ जाती है, तो वो कोलिनियरिटी की एक प्रॉब्लम आ सकती है। वो आप कैसे देख सकते हो, डेटा कोलिनियरिटी चेक करके। ये चीजें मेरे को ऐसे नहीं आई कि एक दिन में मैं ये वर्ड नहीं सीखा, मुझे नहीं आता था पहले, मैं बेसिक्स आप एमडी के टाइम पे सीखता था। और जैसे जैसे आप रिसर्च करते हैं, पेपर्स अपने सबमिट करते हैं, रिव्यूअर को कुछ ना कुछ तो कमेंट देना है ना अपने बताने के लिए कि हाँ हमने कुछ पढ़ा है, तो वो नए नए कमेंट दे के रखे हैं उसको। मैंने नॉर्मल मीन दे के भेजा उनको, उन्होंने बोला इसका ज्योमेट्रिक मीन निकालो, उसके लिए आपको ज्योमेट्रिक मीन पढ़ना है। अगली बार उन्होंने कोई तीसरा एक और मीन था, उन्होंने फिर वो भेज दिया, बोले ये अच्छा नहीं लग रहा, ये बना के, है ना। अभी हमने एक स्टडी करी थी कि उसमें डायबिटीज का ट्रीटमेंट देखना था, ट्रीटमेंट यूटिलाइजेशन कैसा है। तो मैंने उस पर भेज दिया किन लोगों को डायबिटीज था, कितने लोग ट्रीटमेंट ले रहे थे, कितने लोग ट्रीटमेंट नहीं ले रहे थे। रिव्यूअर ने बोला ये बताओ कि जिन लोगों ने भी बोला है कि उनको डायबिटीज नहीं है, अगर उनको हो जाती है उसमें से कितने लोग ट्रीटमेंट लेते, कितने नहीं लेते। फिर मैंने सोचा कि अब क्या करूं, रिजेक्ट होगा। फिर हमने किसी से बात करी, फिर उन्होंने कोई नया टेक्निक बताई, एक हैकमैन सिलेक्शन मॉडल होता है, तो उन्होंने वो लगा के दिया। फिर अभी वो भेजा है, अभी इस पर कोई कमेंट नहीं आए, थोड़ी देर में भेजेंगे वो। तो ये रिव्यूअर्स रेगुलरली जब आप उनसे इंटरेक्ट करते हो तो यू गेट द आउटपुट, और इससे आपकी लर्निंग होती जाती है। ये कोलिनियरिटी वाला भी उन्होंने बताया था, मैंने तभी सीखा मैंने। आपने दो चीजें एक जैसी कंपेयर कर दी, यू आर कंपेयरिंग एप्पल विद एप्पल्स, so you are not going to get good results and you cannot make good estimates. तो पैरामीट्रिक टेस्ट की अगर हम बात करें, तो पैरामीट्रिक टेस्ट जो होते हैं, बिकॉज दे आर more they are from the sample population sample, they have to follow more assumptions, ठीक है। आपको जो रिजल्ट्स है वो पूरी पॉपुलेशन के ऊपर लगाने हैं, तो you have to follow more assumptions. If those extra assumptions are correct, parametric methods can produce more accurate and precise results. It has more statistical power. However, if the assumptions are incorrect, parametric tests can be very misleading. For that reason, they are often not considered robust. Assumptions हमेशा, क्योंकि हम कंप्यूटर में कुछ भी, SPSS में कुछ भी हम इनपुट डालेंगे वो कुछ ना कुछ हमको दे ही देगा निकाल के, है ना। तो अच्छे जो रिसर्चर्स होते हैं वो ये assumptions को साथ लेके चलते हैं, and when they are writing their estimates, they will tell us what assumptions they have looked for. Okay. So we have commonly used tests, Z-test, T-test, ANOVA. These are commonly used. The validation of the assumptions is the fundamental necessity to make credible inferences यूजिंग पैरामीट्रिक स्टडीज। तो कुछ कुछ एजम्पशंस हैं जो हमको रेगुलरली देखना पड़ेगा, बिकॉज आपने जो अपना सैंपल देखा विटामिन डी अगर लेवल्स आपने देखे कि रूरल पॉपुलेशन में कितने हैं, अगर आपने वो क्यूट डेटा सेट कलेक्ट कर लिया, आपके जो रिजल्ट्स आएंगे they may not be of use to everybody. So the scientists who are proposing that vitamin D should be available free of cost is the BSc CSC, है ना? तो उससे हमारा रिजल्ट जो है वो गलत हो गए और उसका यूज नहीं निकल के आया। तो सबसे पहले तो हमको डेटा इंडिपेंडेंस देखनी है, ये एक मोस्ट कॉमन एजम्पशन है जो हम यूज करते हैं। देन रैंडमाइजेशन देखनी है, अगर आप कोई इंटरवेंशन स्टडी कर रहे हैं तो रैंडमाइजेशन प्रॉपर्ली हुई है कि नहीं हुई है, बिकॉज रैंडमाइजेशन इज वन गुड थिंग दैट विल एक्चुअली टेल द रोबस्टनेस ऑफ द एस्टिमेट जनरेटेड। देन इंटरवल स्केल, कैसा इंटरवल स्केल ले रहे हैं, नॉर्मैलिटी ऑफ द डेटा, डेटा जो है वो नॉर्मल कर्व फॉलो कर रहा है कि नहीं कर रहा। देन वी हैव अ मिनिमल सैंपल साइज, जैसे मैंने आपको वो पहलवान वाली बात बताई थी, छोटा सैंपल होगा तो वो नॉन पैरामीट्रिक रिजल्ट देगा, और अगर बड़ा डेटा होगा तो वो पैरामीट्रिक काइंड ऑफ रिजल्ट देगा। ठीक है, तो आइडियली जो हम लोग क्लिनिक्स में फॉलो करते हैं वो एक जनरल रूल हमने लेके चला कि मोर देन 30 जो होगा उस पे हम पैरामीट्रिक रिजल्ट्स लगा के दे सकते हैं, बट ऑल्सो दो रिजल्ट्स आर नॉट वेरी मच जनरलाइजेबल। द रिजल्ट्स आर नॉट जनरलाइजेबल कि आप वो बातें सारी पॉपुलेशन पे अप्लाई नहीं कर सकते। Then we should have data on nominal scale, equality of the data and homoscedasticity की वेरिएशन कितना है। These are basic assumptions, but जो मैंने आपको तीन बताई थी वो क्या थी? The population is normally distributed, the selected population is representative of the general population, or the data is in interval or ratio scale. These are the basic assumptions जो आपको लेके चलनी है अपने एनालिसिस के टाइम पे। ठीक है जी। तो टेस्टिंग द assumptions ऑफ नॉर्मैलिटी, सबसे पहले हम यही देख लें डेटा हमारा नॉर्मली डिस्ट्रीब्यूटेड है कि नहीं है। उसके लिए आप क्या देख सकते हो? स्क्यूनेस देख सकते हो, कर्टोसिस देख सकते हो। वी हैव दिस स्टैटिस्टिकल टेस्ट। नॉर्मैलिटी ऑफ डेटा देखने के लिए या तो आप ग्राफ यूज कर सकते हो, अगर ग्राफ नहीं आपको पसंद तो आप सीधा डायरेक्टली स्टैट्स करा के दे सकते हो, बिकॉज सम रिव्यूअर्स विल आस्क फॉर वैल्यूज, तो वैल्यूज आप स्टैटिस्टिकल टेस्ट लगा के देख सकते हैं। सबसे पहले हम लोग अपना डेटा एनालाइज करने से पहले उसको हिस्टोग्राम प्लॉट कर देते हैं। ठीक है, तो यहाँ पे देखिए एक यूनिमॉडल डेटा, अगर एक यूनिमॉडल कर्व, इसकी जो शक्ल है ये ग्राफ है, ये लाइन जो है ये हमने बनाई नहीं है, बन भी सकती है, कई साइड में नहीं बनती, बट यहाँ पे आप देखेंगे कि जो बीच वाली वैल्यू है वो मैक्सिमम है और जो एक्सट्रीम वैल्यूज है वो धीरे धीरे कम हो रही है। इसमें जो पीक है वो 1 बन रहा है। अगर आप हॉजकिन लिम्फोमा देखोगे कौन से एज में आता है, तो या तो वो बच्चों में आता है या वो बड़ों में आता है, बुजुर्गों में आता है, तो वहां पे आपको 2 पीक मिलेगी उस डेटा में, है ना। तो वो जो आपका डेटा है इट इज नॉट नॉर्मली डिस्ट्रीब्यूटेड। ठीक है, द मीन मीडियन मोड, द मीन मोड एंड मीडियन दे आर ऑल इक्वल। इट इज अ सिमेट्रिकल डेटा, जितना लेफ्ट साइड पे 0 के इस तरफ है उतना ही 0 के उस तरफ होगा। दिस इज अ सिमेट्रिकल डेटा। इट इज एसिम्प्टोटिक, द एक्सट्रीम कवर्स द स्कोर, द एक्सट्रीम वैल्यूज विल नेवर, जो नॉर्मल कर्व की प्रॉपर्टी है, जो नीचे वाली लाइन है ये कभी भी एक्स एक्सिस को टच नहीं करेगी। ठीक है, तो दिस इज वन हिस्टोग्राम एंड नीदर इट इज टू पीक और नॉट इट इज टू फ्लैट, so it is a bell shaped curve. अब ये डेटा जो आपको दिखा रहा है, ये आपको दिखा रहा है कि दिस डेटा इज नॉर्मली डिस्ट्रीब्यूटेड। अदर थिंग वी कैन यूज इज बॉक्स एंड विस्कर प्लॉट्स। ये आपको बता देगा कि जो डेटा है वो आपका इज इट हैविंग एनी आउटलायर्स और नॉट। जैसे वो मैंने पहलवान वाली बात करी थी, इस गांव में एक पहलवान है, ही विल बी द आउटलायर इफ वी आर ट्राइंग टू कैलकुलेट आवर फिजिकल एक्टिविटी लेवल्स। ओके, तो इसमें जो बीच वाली लाइन है ये प्लॉट की, इसमें जो बीच वाली लाइन है ये बताती है दिस इज द मिड वैल्यू, एंड जो इसकी जो ये ऊपर और नीचे वाली लाइन से इन बॉक्स की ये बताएंगे दिस इज द 75th सेंटाइल, दिस इज द 25th सेंटाइल, कि जो वैल्यूज है इसके ऊपर थोड़े से रहेगी 97 तक और नीचे 2.5 तक। इसके बियॉन्ड जो वैल्यूज होंगी दीज विल बी कंसीडर्ड एज आउटलायर्स। तो अगर हमको स्टैटिस्टिकल वैल्यूज देखनी है, if we want to have statistical outputs, what is the normality of the data, then we use this two tests that are available in SPSS, the Kolmogorov-Smirnov test और the Shabirov-Wilk test. Shabirov-Wilk test आप तब यूज करते हैं जब आप छोटा क्लिनिकल डेटा कुछ सैंपल साइज ऑफ लेस देन 30 यूज कर रहे हैं, उसमें आप डेटा में देख सकते हैं नॉर्मलिटी, ठीक है। और अगर बड़ा सैंपल साइज है तो Kolmogorov-Smirnov टेस्ट। अगर तो इसमें पी वैल्यू जो आपकी आती है, इसमें डायरेक्टली कमांड देनी है आपको, आउटपुट और आउटपुट निकल के आ जाएगा। अगर आपकी पी वैल्यू लेस देन 0.05 है तो हम ये जो डेटा है हमारा वो नॉर्मलिटी की assumption को अवॉइड कर रहा है। दिस डेटा इज नॉट नॉर्मली डिस्ट्रीब्यूटेड, एज सिंपल एज दैट। इसको सिंपल ऐसे लिखना है आपने कि एज पर द Kolmogorov-Smirnov test that was significant, the data was not normally distributed and hence we have used non-parametric test. So this is the summary table for the different statistical tests that we are going to use in our journal academics. इसमें level of measurement दिखा रखे हैं हमने, कैसा डेटा है आपके पास, if it is categorical or nominal, the color of the skin, it is black or white, this is nominal data. The rank or ordinal, level of anemia, mild, moderate or severe, and the parameters, the interval, simple your BMI, your body temperature, your systolic blood pressure and vitamin D levels. These are on a continuous scale. तो यहाँ पे आपका ये पैरामीट्रिक डेटा होगा। सैंपल आपका कैसा है, आइसोलेट ये बाइनोमियल डेटा है या फिर वो दो वेरिएबल्स हैं उसमें सैंपल में या फिर एक वेरिएबल। तो अगर तो दो सैंपल है और वो इंडिपेंडेंट है, कि लाइक यू आर गोइंग टू कंपेयर द विटामिन डी लेवल्स ऑफ मेल एंड द फीमेल, सो द डेटा ऑफ मेल इज नॉट comparable to, it is not related to the data of female, so it is independent variable, independent kind of sample. क्या होगा, मैं ऐसे देख रहा हूँ कि मैं एक्सरसाइज करने से पहले कितना था और 6 महीने एक्सरसाइज करने के बाद कितना हुआ, तो उसमें आई एम माई डेटा इज रिलेटेड टू माई सेल्फ ओनली, तो दिस इज द पेयर्ड डेटा, ठीक है। तो जो ये डेटा होगा हमारा, दिस इज डिपेंडेंट डेटा, because the output data at 6 months, it is dependent on the baseline data collected before the intervention. So this is the dependent data. So here we have different kind of test, और कभी कभी दो सैंपल से ज्यादा भी आप ले सकते हो, माइल्ड मॉडरेट सीवियर ले लिया आपने से फॉर एग्जांपल, है ना, या फिर मैं देखना चाहता हूँ कि BMI ऑफ माइल्ड मॉडरेट सीवियर लोगों का कैसा है, तो उसमें हमारे पास 3 सैंपल आ गए। और कभी कभी डिपेंडेंट वेरिएबल भी हो सकते हैं, तो इसमें ये डिफरेंट लिस्ट ऑफ टेस्ट है जो हम रेगुलरली यूज करते हैं। तो हाउ टू सेलेक्ट द टेस्ट, इफ द डेटा इज अवेलेबल एट अ इंटरवल, इफ वी आर हैविंग स्मॉल इंटरवल्स इन बिटवीन, इट इज अ कंटीन्यूअस डेटा, है ना। अगर कंटीन्यूअस नहीं है तो वी हैव टू यूज अ नॉन पैरामीट्रिक टेस्ट। अगर कॉन्टिन्यूस है तो आर द सैंपल्स इंडिपेंडेंट, अगर है इफ द सैंपल इज लार्ज, अगर लार्ज है देन वी यूज फॉर सिंगल ग्रुप, देन वी यूज जेड टेस्ट। अगर ज्यादा ब्रेस्ट सैंपल है और उसमें ग्रुप्स भी ज्यादा है तो वी यूज टी टेस्ट। और नाउ कमिंग ऑन टू SPSS, आप लोगों ने कितने ने SPSS पहले यूज किया है? अच्छा, ओके ओके। So SPSS it is a statistical software जो हमको हमारे डेटा इन्फ्रेंसेस बनाने में हेल्प करता है, ठीक है। तो इसमें आगे लेके जाए फिर, अगर आपको थोड़ा सा बता देता हूँ। हाँ, तो इसमें इस डेटा से, ये जो सॉफ्टवेयर है इसमें आपको बड़ी सारी ऑप्शन होती है जिससे आप डेटा एनालिसिस कर सकते हैं। तो जो ये सबसे बेसिक स्टेप्स है, सबसे पहले जो आपने डेटा अपने एक्सेल में इंपोर्ट जो बनाया था उसको आपको इसमें इंपोर्ट करना रहेगा। और इसके लिए फाइल में जाके ओपन एंड देन ओपन द प्रोजेक्ट, वट एवर प्रोजेक्ट यू वांट टू ओपन। इसमें ये फाइल इसी फॉर्मेट में भी सेव हो सकती है, डायरेक्टली एक्सेल से इंपोर्ट भी हो सकती है। ओके, तो इसमें दूसरे ऑप्शन है जो एडिट वाले ऑप्शन, जो अवेलेबल डेटा सेट है उसको आप चेंज कर सकते हैं। जैसे फॉर एग्जांपल आपने विटामिन डी लेवल्स ले लिए थे, अब आपको ये पता 30 से ऊपर जो है वो हम नॉर्मल बोल देंगे, 30 से कम जो है उसको हम डेफिशिएंट बोल देंगे। तो आपको इस डेटा की कोडिंग करनी है, तो ये सब ऑप्शंस यहाँ पे हमारी एडिट में अवेलेबल होंगी, और ट्रांसफॉर्मेशन में भी ये डेटा अवेलेबल हमारे पास अवेलेबल रहेगा। उसके बाद एनालिसिस में यहाँ पे आपने फाइल ओपन कर दी थी। हाँ, इसका जो दूसरा पार्ट है डेटा की दूसरी शीट जो है, जो मैंने आपको बताया डेटा बना के रखनी है, यहाँ पे बना के रखनी है अगर आपको डेटा 1 पॉइंट चाहिए, फॉर एग्जाम्पल हमने डेट दिया था, डेट को किसी में चाहिए आपको लिमिट कर सकते हो, डेट को फिगर है कि इट शुड नॉट गो बियॉन्ड 3। अगर चीजें एक भी नॉर्मली रेफरेंस आप डेटा जो भी तो 60.1 के है या 60.15 के है, उससे मेरे रिजल्ट और फर्क नहीं पड़ेगा। जरूरत पड़ सकती है, डेफिनेटली नॉट टू हैव decimal up to 5 है, but as per your study. Then we have data for data. Data आपको is going to come. अगर आपने डेटा कोडिंग का यूज की तो कोडिंग की वैल्यू अगर आप यहीं पे डालोगे तो कोडिंग के वो कोडिंग की जो ओरिजिनल वैल्यू है उनके साथ आपको आउटपुट मिलेगा, तो यू डोंट हैव टू फॉर्मेट योर टेबल। यहाँ देखने के लिए एनालाइज में जाते हैं, और
Just read it out, no? Read it out.
As you said, the subject should be equitable. So it is only possible for those students where the research is unbiased.
No, no, no.
That was the previous question.
Okay, okay. I am 251. The biggest number is the latest. Also,
No, these are all.
नीचे करिए please जरा. नीचे करिए.
इसको नीचे ले आइए, scroll down, scroll down.
Scroll down. Voice is not clear. Voice is not clear.
Not audible. These are not for
I am
you.
sorry.
ये भी 3 बजे थोड़ा.
चलें फिर next.
Thank you so much.
आप इधर आ जाइए. It was such a wonderful experience. Verma shared his knowledge with us today. I request the members of the organizing committee to please facilitate.
Professor Rajkumar.
Okay.
As we move towards the culmination of today's conference, I invite the last speaker of the day, Professor Rajkumar, to speak on the topic Fundamentals of Drug Design. Professor Rajkumar is currently the presiding dean, School of Health Sciences and head, Department of Pharmaceutical Sciences and Natural Products at the Central University of Punjab. Along with publishing around 100 articles in esteemed journals, both national and international, Professor Kumar was also chosen as a Fellow of the Royal Society of London in 2022. With his interests in the field of both medicinal chemistry and drug discovery, what better person to share his knowledge on the basics of fundamental drug design than Dr. Kumar himself. I request you to join me as I welcome Professor Rajkumar to take the stage and enlighten us with his words of wisdom.
Yes, working, sir. Thank you very much for wonderful introduction. I would like to thank, first of all, the organizers, Central University of Punjab, AIMS, INEAS, for inviting me and having me here. Actually, may I know the background of the persons who are attending, like chemistry, biology, or biology? Please raise your hand. Biology. Very good. And physics.
Biology को very good करने का.
दोनों very good.
फिर आप कैसे
मेरा because connection. Okay. Next. So I will keep my pace according to that. So
Food science and technology.
food science technology, very good. I said very good. Please note it. Okay. So before we start, molecular modeling. Actually, I was thinking, what should I share with respect to molecular modeling? Before you go to the molecular modeling, we should know the basic aspects. Food science people. So they know. Somebody's talking. So food science people, they know the value of amino acids, right? Carbohydrates, amino acids, and other things. So our body has receptors, enzymes, and people are working on to inhibit those enzymes which are overexpressed or which are working in a higher rate, which are not required, right? And some receptors which are overexpressed in the body in a disease condition, in cancer or some other condition. So if we inhibit their working. So how we can inhibit them? We can design some compounds which are called, later on they're called drugs. They bind to them, and they sit in the particular pocket, and they inhibit their function. Once they occupy the site, they inhibit their function. And once they inhibit the function, what will happen next? Then the next sequence, downstream pathways do not occur. Okay. So in fundamentals of molecular modeling, one must know that, what is required. So anybody knows drug discovery process? So if you know the drug discovery process, it is not easy. It takes 14 years, 15 years for a molecule to come from the, bench to bedside or in translational value. Okay. So it is not easy. So this is the whole story, whole sequence of a drug discovery process. Okay. So you need to have, here we people work actually. Professor Anjana Munshi, myself, and Dr. Abhinav is with us. He's a very good friend of mine. So we people work in the mostly before preclinical, in discovery stage. Okay. We discover the drugs, we check their in vitro and in vivo efficacy, their activity, efficacy, toxicity. Then the things move further. Okay. So we have to screen so many compounds, thousands, more than 1,000 compounds. It's not a joke. Okay, discovering a molecule. So here the main workforce is required. And here the chemist, biologist, physicist, everybody is required here. It's a molecular biology, whatever you call, pharmacology. So everything is required here to discover a particular lead molecule. We call it as a lead molecule. That will become a drug later on if it passes all the things, preclinical and then clinical. So you know that it's taking 12 to 15 years. So why not, if we start and if we are synthesizing some molecules randomly or discovering from or isolating from the natural products, then testing. Okay. Earlier, in 1990s, high throughput screening came into the picture. High throughput screening means you have so many molecules, you have designed so many molecules, synthesized so many molecules, and you have a high throughput assay, and you are seeing that which compound is more active in vitro. Okay, enzymatically or receptor wise. Okay, in vitro. So, but that was a time consuming, and you might have false positive or false negative. But again, that is a not only time consuming, but its money is also involved. So then molecular modeling came into the picture, that why not to design, why not to have, if we know the crystal structure of protein, enzyme and receptors both are made up of proteins, and proteins are made up of, anyone? Amino acid. So if protein structure we know, crystal structure of a protein we know, and we know where the natural ligand is sitting in the protein. I will take one example and we will keep on doing that. Like, for example, there is a disease called gout. Okay. So there is an enzyme involved, xanthine oxidase. Okay. So what happens in our body, purine metabolism takes place, xanthine gets converted into uric acid. And when this enzyme is overexpressed, xanthine, more xanthine is getting converted into uric acid, which uric acid, at particular level, like if the level of uric acid increases more than 6 mg or 6.5 mg per deciliter, it is in the blood, and it's acid that's deposited into the joints when the concentration is high. It's called hyperuricemia. And when it is deposited in the great toes and others, it starts paining. Body starts paining. So that will have other complications, cardiovascular side effects. So some other problems are there. So there are, what you call secondary effects of the hyperuricemia. So uric acid increase, then hyperuricemia, then gout. That situation is called gout, and then other complications. So here I'm talking about that enzyme, xanthine oxidase. So xanthine is a natural ligand of xanthine oxidase. So xanthine oxidase is a macromolecule. So in molecular modeling, we would like to know the interaction between a small molecule and the big molecule. The big molecule is called macromolecule. Don't you think in our body also, how our body sense in the cells, how the cell communication takes place, cell to cell communication, as well as the how the nucleus is communicating to the outside world of the cells, means in the cytoplasm. So how it's happening? Protein interaction, and small molecules also signaling takes place. So there is an interaction between small and macromolecules. So if we come to know how they interact, how they talk. Okay, so that is nothing but we will take help of molecular property. That means one protein comes to the protein, a small molecule or another protein comes in contact and gossip. And then the communication takes place and then it leads to the other effects. People, you might be seeing Big Boss. Big Boss में यही होता है ना कि एक दूसरे को चुगली लगाते हैं उसके बाद नया इफेक्ट पैदा हो जाता है. Okay, so same way the cell signaling कैसे होती है, it's an interaction. So this, if we have some program, why not to, if we can discover, if we can design some, design तो आप कर सकते हो ना computers पे, design some molecules, you have the crystal structure of protein, why not to filter them through that protein, which one sits best in the protein, that can give an idea to you. Yes, we can go ahead with the synthesis of this protein. If not, if it's previously synthesized, no problem. You might have seen repurposing of the drugs during COVID-19. So people have done this, right? So we have already FDA approved drugs where efficacy, everything is known, like antiviral drugs. So what they did, they know that because every month new structure of proteins was coming up, SARS-2 virus and other things, you know, the spike protein and other proteins. Then what the molecular modeling took a boom, and many medicinal chemists and discovery scientists, they screened many already existing molecules through those proteins and found out some good leads. Some were only in the paper and some came into the market. So repurposing of the drugs. So it's a very good tool, you know, molecular modeling techniques. So if we can reduce the time, we can design some compounds in a computer and screen them or filter them to a protein. So we can get, there are some chances that we can get a better lead. Okay, but you may get false positive or false negative again because it is a, and you have to have one standard also in this case also, as we take in case of in vitro studies. No, you know, in case of wet lab studies, we take always standards. So here also a positive control is required. So so it is generally called computer aided drug design, CAD. So if you go for CAD, so what you can do, you can create a molecule hypothetically or whatever, and you should know the target where you want. If you do not know target, then what will you do? So then the technique is different. Still you can make use of computer, machine learning. You can still take help of computer and making a QSAR study. That is called quantitative structure activity relationship. You know some existing data, you have some biological data, and then you can align those biological data and see how the biological data is fluctuating with respect to the structure of the molecule. That's why I asked how many of you are in chemistry right now. Okay, so because we as a medicinal chemist assume that the activity is a function of structure, or structure is a function of activity. It means that if you just change the structure of a compound, the activity will vary. The compound may be very active or may be very inactive. All of you know there is a compound thalidomide. Okay, thalidomide was withdrawn because of the stereochemistry. So it was such a, people were using this, but it came later on, it came up with a disease, comelia and other problems. So teratogenicity was observed. So just one chiral center was flipped. So one was R, other is S. You might have heard stereochemistry. So because of just a stereochemical change, one drug which was active became toxic, not inactive. So there are three things: active, inactive, and toxic. Active deuteromer, inactive distomer. Okay, but toxicophore, if it leads toxicophore, think about how it behaves, because our proteins are also chiral. They are also asymmetric. They are not symmetric. That's why chiral, nature is also chiral. So chiral likes chiral, and chiral, senses chiral. Okay, so that's why the chiral word came into picture. So we can make use of CAD in every aspect of the drug discovery. How we can start with, like Professor Anjana Munshi does, like in genetics also, use bioinformatic tools. Here you can use molecular modeling or help of computer-aided drug design. Bioinformatics, reverse protein structure prediction. Even if two proteins are similar, okay, and crystal structure is not reported for one protein. So what we can do, another approach is we can design, we can build up a protein by just seeing how closely it is related to the other protein. So it is called homology modeling. Okay, so we can use all these things. And if you really know the crystal structure of the protein, you can just download it from the RSCD, bank. It's a bank where all people deposit their protein structures, crystallized structures. Physicists are there. So X-ray structures, biophysicist people, they crystallize, co-crystallize also, like protein with the inhibitor or its substrate. Okay, activator भी हो सकता है, inhibitor भी हो सकता है, कुछ भी हो सकता है. तो protein अकेले भी हो सकती है crystallize का. Okay, so you can download and you can, whatever compound you have designed, you can filter them, pass to them. How does they bind to the protein? So you can validate your target druggability, track. So in each field, be discovering, yes, library design. Once you know, for example, allopurinol is a good inhibitor of xanthine oxidase. I took example, right? Xanthine gets converted into uric acid. Okay, so if we inhibit xanthine oxidase, what will happen? Xanthine will not be converted into uric acid. So if we know that allopurinol, by chance some people told me, okay, allopurinol is an inhibitor of xanthine oxidase. So now we know the structure of allopurinol. It has, I don't know whether it has come from random screening or through molecular modeling. But once you have one inhibitor in your hand, and you know, okay, if allopurinol I am using, it is giving me Stevens-Johnson syndrome, some skin hypersensitivity, some other reactions. Can we avoid those toxicity problems? Can we avoid those side effects by making use of molecular modeling? If I know my compound is like doxorubicin and others, they are having cardiotoxicity. Can we avoid their cardiotoxicity and design a better compound? So that problem can be a good problem in your research methodology. So I'm linking with your research methodology, conference, today's topic, main topic. Okay, so if I know the structure of allopurinol, if I put some other groups and see, then dock into the protein. I want to have now better score or better inhibitor as compared to allopurinol. What I will do? Inhibitor. So one thing is potency, other is toxicity. I'm not, first aspect I am looking for potency. What I'll do? I will just change the sum of the structure because I have a lead molecule. I will just do lead optimization. That means I will do some structural change in the allopurinol and redock it into the protein, and I'll see how does it fit into the protein. Is it a tight binding or just loose binding? Okay, that means it should be tightly sit into the pocket of the protein. If it tightly sits and for longer time, that means I can say that it will remain. But in drug discovery, we do not, we actually appreciate reversible kind of binding. Means थोड़ी देर बैठेगा, फिर निकल जाएगा, eliminate हो जाएगा, metabolize हो जाएगा, कुछ भी. But there are many irreversible inhibitors also. So here, lead optimization, and one more thing. Allopurinol का structure आपको पता है. Then you just change the structure. So many compounds you can design, 1,000, 10,000, and then filter them. So you can make a library design, dock them, get the score, best score. इसमें molecular modeling में we have a good software which gives scores also. Like topmost score, कुछ scores plus में देते हैं, कुछ some software gives score in minus. So in some cases, higher the minus means जितनी ज़्यादा minus value होगी उतना top score. And in some cases, like in Gold and other softwares, they give positive value. Higher the positive value, better is the score. So you can get a better score. You can arrange them, you can align them, you can see them how it is sitting into the pocket and compare it with the standard. क्या सारी interaction है? Then de novo design क्या करते हैं? Pharmacophore क्या होता है? It's a basic moiety which is responsible for the drug action. Okay, जो minimum requirement है, that is required. अगर वो हटा दोगे, allopurinol में अगर purine ring चाहिए, अगर purine ring ही नहीं होगा, then activity will never come. It will never inhibit the xanthine oxidase. So minimum structural requirement for a compound, to have the biological action or binding with the protein is called a pharmacophore. Toxicophore भी होता है. Toxicophore जो toxicity पैदा करे. Okay. Then target flexibility. So all of them you can do. Lead optimizations में you can also use अगर protein का structure नहीं पता, so you can go for the QSAR. एक होता है SAR. SAR होता है structure, activity, relationship. चला था आपने क्लोरो की जगह ब्रोमो लगा दिया, एक्टिविटी चेंज हो गई. ब्रोमो की जगह फ्लोरीन लगा दिया, एक्टिविटी. आप सब साइंस के हो, you know क्लोरीन, ब्रोमीन, आयोडीन. साइज बढ़ रहा है क्लोरीन से आयोडीन में. तो जैसे जैसे साइज बढ़ेगा, अगर मैंने क्लोरीन की जगह पे आयोडीन लगा दिया, तो यू कैन थिंक ऑफ क्या पॉकेट इतनी सी है. अगर हम पॉकेट में पुश करते हैं कंपाउंड को, तो क्या आयोडीन वाला वो डिपेंड करेगा कितनी बॉन्डिंग है.
फ्लोरीन है, शायद ये हाइड्रोजन बॉन्डिंग दिखा दे, बिकॉज इनिशियली आई टोल्ड यू प्रोटीन इज मेड अप ऑफ अमीनो एसिड, और अमीनो एसिड्स में प्राइमरी स्ट्रक्चर, सेकेंडरी स्ट्रक्चर, टर्शियरी एंड क्वार्टनरी प्रोटीन्स का आपको पता होना चाहिए। तो क्वार्टनरी स्ट्रक्चर्स में जब प्रोटीन में जाएगा कंपाउंड, तो कैसे बैठे, क्या पता आयोडीन बड़ा साइज है वो उसको बाहर ही फेंक, इट कैन नॉट प्रॉपर्ली कैविटी। सो व्हाट विल हैपन, the compound having iodine moiety may not be active because it will be pushed out. Okay, and fluorine, maybe bromine is better, fluorine is loose, छोटा है, bromine or bromine is optimum हो सकता है। Sometimes we use fluorine in case of methyl, it is called isosterism, क्योंकि मिथाइल जो है वो जनरली body COH बना देता है, decarboxylation हो जाती है, then we go for fluorine. So there are many things you have to take into account. So we can QSAR, structure activity relationship, we can quantify it. It is called quantitative structure activity relationship. ये 2D भी हो सकती है, 3D भी हो सकती है. So it could be 2D QSAR or 3D QSAR. 2D means if you take 2 functions, 3D means if you take 3 or more functions. Okay. Then structure based optimization or ligand based optimization. Structure based मतलब you know the structure of the protein. Okay. Now you can design the new compound. और लिगेंड बेस्ड जो ये उनके लिए कह रहा हूं जो पूछते हैं ना कि ड्रग कैसे डिस्कवर होती है, और लिगेंड बेस्ड का क्या हुआ जिसमें आपको आपके पास बाय चांस हिट मॉलिक्यूल है, पहले जितने भी मॉलिक्यूल्स पहले डिस्कवर हुए हैं बेसिकली रैंडम से हुए, राइट, पहले तो ऐसा रेशनल कुछ ड्रग डिस्कवरी नहीं है ना, सो बाय चांस हुए हैं, सेरेंडिपिटस हुए हैं, पेनिसिलिन देखिए, ओके, सो हाउ पेनिसिलिन वाज डिस्कवर्ड यू पीपल नो। नाउ फर्दर जो पेनिसिलिन की चेंजेस आई हैं, बेंजोइल पेनिसिलिन के बाद उसके बाद मेथिसिलिन, रेजिस्टेंस, वो सारे बने, सो हाउ दे आर going and interacting with the protein, that is important. Can we modulate the activity but just by changing the structure and seeing how it happens? So अगर हम 50 कंपाउंड बना ले और 50 कंपाउंड की हमने फिल्टर कर लिया प्रोटीन्स में, हमें कुछ वैल्यू आ गई, why not we synthesize those only top scoring compounds? Why to synthesize 1000 compounds? एक तो अगर वैलिडेट करना है, what you should do, synthesize only top 10 compounds or 5 compounds and एक वो बनाओ जिसका सबसे स्कोर कम आया था, and validate your hypothesis in the wet lab. You may have the same, same answer, or you may deviate from the results which you have. If you are deviating, then definitely you should talk about some other parameter. You should take into account the other parameters also. It is possible. Okay. If you get the same sequence, you are lucky. Okay. And not only that, if you have synthesized the molecule, you can check its ADME property. Because drug goes inside, then absorption, distribution, metabolism, excretion, and even you can predict toxicity. People are working on these tools and they are getting successes also. Okay, so you can avoid the toxicity also. If it is following rule of Lipinski, rule of 5 भी बोलते हैं. But there are many compounds, जैसे 500 molecular weight अगर डाल्टन तक weight है, तो हम कहते हैं ये compound drug-like property देगा. Drug-like, small molecule की बात कर रहा हूँ. Drug-like property देगा. फिर लोग कहते हैं, but there are many exceptions भी हैं, erythromycin, right? It's a very big molecule. Taxol is a very big molecule. Okay, but generally, in general, there are some set of rules that it will say that this compound will be having a drug-like property. See, log P कितनी होनी चाहिए? ज़्यादा होगी तो blood-brain barrier क्रॉस कर जाएगी और आपको ब्रेन में दवाई एक्यूमुलेट होना शुरू हो जाएगी. बहुत कम होगी तो absorb नहीं होगी. इतनी होनी चाहिए जो ऑप्टिमम हो, राइट? फिर उसके बाद आपकी लॉग पी भी हो गई, मोलिकुलर वेट भी हो गया, फिर उसके बाद आपके कंपाउंड में हाइड्रोजन बॉन्डिंग कितनी होनी चाहिए, ठीक है, वो सॉल्युबिलिटी को मैटर बताएगी, परमिएबिलिटी, सॉल्युबिलिटी, ठीक है, परमिएबिलिटी ब्रेन से और सेल मेम्ब्रेन से, वो चीजें हैं ड्रग डिस्कवरी. एंड दैट मींस यू हैव टू सी द फिजियोलॉजिकल बेस्ड फार्माकोकाइनेटिक्स. एक होता है फार्माकोकाइनेटिक, एक होता है फार्माकोडायनामिक्स. किसी को डिफरेंस पता है? फार्माकोकाइनेटिक हम तो ऐसे, हाँ बताइए बेटा.
Pharmacokinetics is basically what body does to the drug, and pharmacodynamics is the power of the drug on the body.
What the drug does to the body. हम भी ऐसे रटा मारा करते हैं. ऐसी डेफिनेशन थोड़ी और भी है इसकी अगर हम पढ़ें, बट इसकी बहुत अच्छा है. So what the body does to the drug is pharmacokinetic, and what the drug does to the body, हम पहले कर रहे हैं कि हम इंटरेक्शन देख रहे हैं ड्रग एंड प्रोटीन की, क्योंकि जनरली प्रोटीन्स है, डीएनए में भी प्रॉब्लम होती है, एंटीकैंसर में हम डीएनए को भी टारगेट करते हैं, ठीक है. तो प्रोटीन्स और हम ड्रग की जो इंटरेक्शन देख रहे हैं, दैट इज नथिंग बट फार्माकोडायनामिक्स, ठीक है. इसके ड्रॉबैक्स भी है, वो भी डिस्कस करेंगे मोलिकुलर मॉडलिंग के ड्रॉबैक्स. वो हम आपसे ही फिर डिस्कस करेंगे। और फार्माकोकाइनेटिक्स क्या है? व्हाट द बॉडी डज टू ड्रग। अब बॉडी क्या है? ड्रग हमने खा ली, उसके बाद बॉडी ने क्या किया? एब्जॉर्प्शन, डिस्ट्रीब्यूशन, मेटाबॉलिज्म, एक्सक्रीशन, ये तो बॉडी अपने आप ही हो रहा है ना, ये तो बॉडी डज टू द ड्रग। ओके, सो that also we can predict with the help of, I have a friend Bhagwat, he is in Washington State University and he works on transporters कि ड्रग तो बनी बनाई है, वो कौन से ट्रांसपोर्टर के थ्रू जा रही है और उसमें इन सिलिको अप्रोच यूज करते हैं। इन सिलिको मींस कंप्यूटेशनल अप्रोच। यस, आप मेरे बताओ कि हाउ इट क्रॉसेस द मेम्ब्रेन्स, बिकॉज इट इज अ पैसिव डिफ्यूजन भी होता है, एक्टिव भी होता है। एक्टिव के लिए आपको ट्रांसपोर्टर्स चाहिए, ATP dependent या others. Okay, so in all cases we can simulate, we can have a simulation. अगर डॉकिंग भी करनी है, we can go to the simulation. Actually, कितनी देर रिसेप्टर के साथ हमारा जो ड्रग मॉलिक्यूल है, जो बनना है बाद में ड्रग मॉलिक्यूल, वो कितनी देर रहेगा, सिमुलेट करते हैं। ओके, तो दिस इज द प्रोसेस। मैंने आपको बताया कि वर्चुअल स्क्रीनिंग इज नथिंग बट कि हम स्क्रीन करना वर्चुअली। मेरे कंपाउंड्स सही दिख रहे हैं, सबकी एक्टिविटी सही आ रही है, वर्चुअल एक्टिविटी है नहीं, वर्चुअल एक्टिविटी। सो इट्स लाइक फनल, लाइक you have designed so many compounds which are having drug like properties। आप डेटाबेसेस भी हैं, जिंक डेटाबेस है, पबकेम है, बहुत सारे डेटाबेसेस हैं जहाँ पे ऑलरेडी कंपाउंड लोगों ने डाले हुए हैं जो सेंसाइजेबल भी हैं और वो पड़े हुए हैं। आप नेचुरल अलग लाइब्रेरी है, तो आप बने बनाए कंपाउंड्स की लाइब्रेरी भी उठा सकते हो। ओके, एंड जस्ट फिल्टर देम, फिर उसके बाद टॉक्सिक प्रिडिक्शन भी देख सकते हो। इवन लोग काइटोक्सिक करते हैं, वो HERG करके जीन होता है, ह्यूमन से रिलेटेड गो जीन, उससे भी आप फिल्ट्रेशन कर सकते हो। एंड देन उसका पोज चेक करना, बैड पोज, अच्छा पोज, जब बेस्ट स्कोरिंग आ गया, थोड़ा सा इसमें आपको अच्छे से काफी टाइम स्पेंड करना पड़ता देखने के लिए। देन उसके बाद आप उसकी लास्ट में एडीएम देखते हो कि सबसे बेस्ट जो एडीएम वाला है, तो कुछ ही मॉलिक्यूल आए, कितने 10, 12, 50 मैक्सिमम। अगर आप 1 लाख की दे ले रहे हो, बहुत ज्यादा दे रहे हो, तो आपको 1000 के आस। लेकिन जो ये 1 लाख सिलेक्शन है ना, यहाँ से आपका दिमाग शुरू होता है। आप सिलेक्ट कैसे करोगे? यहाँ से आपका इंटेलेक्चुअल थिंकिंग बेसिस क्या है कि सारे के सारे जिंक डेटाबेस में 50 लाख भी हो सकते हैं मॉलिक्यूल, सबको चढ़ा दोगे बलि पर, इट इज नॉट पॉसिबल, राइट? सो हियर थोड़ा सा आप इंटेलेक्चुअल नॉलेज यूज करो कि आपकी प्रोटीन का स्ट्रक्चर कैसा है, आपकी प्रोटीन का नेचुरल लाइगेंड क्या है, उसमें किस तरह का स्ट्रक्चर, क्या मेरे जो डेटाबेस ले रहा हूँ मुझे किस तरह का, मुझे कुंडलिन टाइप कंपाउंड चाहिए या मुझे पेरिडिन टाइप कंपाउंड चाहिए, इस तरह से थोड़ी आपको नॉलेज अप्लाई करनी पड़ेगी रिसर्च मेथोडोलॉजी के साथ। ऐसा नहीं कि कुछ भी डेटाबेस उठाया और आपने सारे कंपाउंड को डॉक कर दिया, आपको कितने दिन लग जाएंगे, महीना लग जाएगा, एक कंप्यूटर बेचारा काम ही करता रहेगा। You have to be smart, right? You cannot select all the molecules. फिर उसके बाद you will get the best molecules. अब मैंने बोला ना आपको कि पहले 10 या 15 मॉलिक्यूल बनाओ और एक मॉलिक्यूल इनएक्टिव भी बनाओ, जो आप कंप्यूटर ने बताया ये इनएक्टिव। फिर आप चेक करो न्यूट्रॉन में क्या आपके रिजल्ट्स पैरेलल आ रहे हैं। If they are coming parallel, fine. If they are not coming, go back and see what is the problem. What other things are interfering in your assays. So in silico assay है, ये in vitro assay, दोनों को आपको क्या वो दोनों वैसे तो पैरेलल नहीं करेंगे, लेकिन एक ट्रेंड ऑलमोस्ट वैसा आया तो यू आर लकी। ओके, so मैंने बताया there are 2 types of drug design methodology. One is structure based drug design, other is ligand based drug design. Structure based में क्या होता है, if we know the crystal structure of the proteins, जैसे आजकल लोग प्रोटेक्स पे काम कर रहे हैं, उसमें ऑलरेडी कुछ स्ट्रक्चर है, सारे स्ट्रक्चर नहीं है, लेकिन अगर आप प्रोटेक्स पे काम नहीं कर रहे तो मैनी स्ट्रक्चर यू विल गेट। क्रिस्टल स्ट्रक्चर आपको मिल गया, उसमें ऑलरेडी एक इनहिबिटर बैठा होगा, आप वर्चुअल मोड में जाओ, उसका इनहिबिटर अलग करो, अपने कंपाउंड डोप करो एंड यू विल गेट द। तो आपने एक प्रोटीन, कितनी बड़ी प्रोटीन है, छोटा नहीं बहुत बड़ी प्रोटीन होती है, और उसके अंदर देयर आर मेनी रीजंस जहां पे बाइंडिंग हो सकती है। जहां पे मेन बाइंडिंग होती है दैट साइट इज कॉल्ड एक्टिव साइट। ओके, फिर एलोस्टेरिक साइट भी हो सकती है, द साइट व्हिच इज अदर देन द एक्टिव साइट। तो मॉलिक्यूल को बेचारे को क्या पता है, वो तो जहां उसे जगह मिलेगी वहां जाके बैठ जाएगा, है ना। तो द एक्टिव साइट वो, जैसे मैंने बोला ज़ैंथीन ऑक्सीडेज के केस में जहां पे ज़ैंथीन बाइंड करता है, अगर वहीं पे मैं अपना कंपाउंड भेजूं उसी एक्टिव साइट में, दैट विल बी कॉल्ड एज द एक्टिव साइट इनहिबिटर, है ना। मेरा इनहिबिटर जा रहा है, वो कॉम्पिटिटिव इनहिबिशन होगा, जब उसकी कंसेंट्रेशन ज्यादा होगी तो वो नहीं होगा, जब उसकी कंसेंट्रेशन ज्यादा होगी तो वो नहीं होगा। ओके, सो देयर विल बी कंपटीशन कि कौन पहले बैठेगा, वो एफिनिटी पे डिपेंड करेगा। ओके, देन एलोस्टेरिक कुछ भी हो, चाहे xanthine है चाहे नहीं है, कंपटीशन, बट जो मेरा कंपाउंड है उसके आके एक और साइड पकड़ ली चुपके से जो प्रोटीन के पीछे है, एंड दैट विल जस्ट सिट। और जैसे ही वो सिट करेगा उसके बाद प्रोटीन कंफर्मेशन चेंज हो जाएगी, प्रोटीन पर एक्टिव, तो ऐसी कंफर्मेशन चेंज होगी जो मेन साइड थी एक्टिव साइड तो छोटी होगी। तो indirectly it is affecting the binding of the substrate, natural substrate. Allosteric binding साइड पे भी कंपाउंड्स बनते हैं, ठीक है। कई बार ऐसा भी होता है, लोग डिस्कवर करते हैं कि ये हमारा एक्टिव साइट इनहिबिटर है, बट वो दोनों होता है, कुछ उधर जा रही है कुछ वहां जा रही है। कैसे पता लगेगा? कैसे पता लगेगा? माइकलिस मेंटल इक्वेशन। फिर आपको लाइल लीवर बर्थ प्लॉट भी ड्रॉ करने पड़ेंगे, ठीक है, इनविट्रो में। ओके, और दूसरा मेथड है लिगेंड बेस्ड। आपके पास लिगेंड है, लिगेंड मतलब ड्रग है, ऑलरेडी रिपोर्टेड है। तो कुछ पेपर्स आते हैं जिसमें 50 मॉलिक्यूल दिए होते हैं, साथ में उनकी आईसी दी होती है, ओके, एक्टिविटी दी होती है। तो आप उस कोरिलेशन के बेसिस पे नए मॉलिक्यूल डिजाइन कर सकते हो कि वैसे तो रिसेप्टर्स अच्छे से नहीं, रिसेप्टर्स का वैसे टेक्नोलॉजी डिजाइन करो या फिर आप उसको वो स्ट्रक्चर पे डिपेंडेंट है, प्रोटीन के ऊपर इतना डिपेंडेंट नहीं। तो दोनों टेक्निक से इंपॉर्टेंट है। तो ये एक स्मार्टली अगर आपको ड्रग डिस्कवरी में काम करना है, ये फ्लो चार्ट आप एज ए कंप्यूटर फ्लो चार्ट आप यूज कर सकते हो। वहां से शुरू करो, एक ड्रग टारगेट चूज करो, वहां से फिर धीरे धीरे हो सकता है यू मे एंड अप विद द रॉन्ग ड्रग टारगेट, नो प्रॉब्लम, बट आपको शुरुआत तो करनी पड़ेगी। तो वहां से शुरू करो एंड यू विल सी क्या आपका इनहिबिटर माइक्रोमोलर में है, नहीं है, क्या हम लीड को मोड़ी जो हमने डिजाइन फाइनल आया हमारे हाथ में, क्या हम इसकी एक्टिविटी और बढ़ा सकते हैं, कैन वी मेक इनटू नैनोमोलर एक्टिव, माइक्रोमोलर से नैनोमोलर कैन बी इंक्रीज इट, इन सिलिको ऑप्टिमाइज करो, फिर डेटाबेस में डालो, ये सब भी चल सकता है। लेकिन फाइनली आंसर जो है आपका वो कौन देगा? इन विट्रो करना ही पड़ेगा। इन विट्रो के बाद में इन विट्रो में नहीं जाते, अक्सर करते हैं देयर आर अदर इश्यूज, राइट, भाई एडीएमई या और टॉक्सिसिटी भी हो सकती है, ऑफ टारगेट इफेक्ट्स, वी डू नॉट नो कि हम तो ये जिम करके चल रहे हैं ना, सिंगल टारगेट सिंगल कंपाउंड। अरे भैया ऐसी ऐसी पॉकेट्स और भी हैं। मैं आपको एग्जांपल देता हूं, टायरोसिन काइनेसेस। टायरोसिन काइनेस पूरी फैमिली है, 500 से ज्यादा प्रोटीन्स हैं और सभी के सभी प्रोटीन्स एटीपी यूज करते हैं इन इट्स एक्टिव साइट। तो अगर हम एक कंपाउंड एक टायरोसिन काइनेस के लिए बनाते हैं, इट इज वेरी लाइकली दैट माय कंपाउंड विल इनहिबिट द अदर टायरोसिन काइनेसेस आल्सो। थोड़ा स्मार्टली, molecular modeling still has the answer. You have to go and deeper and see the structure. What is the structure of active site? Okay. मैडम थोड़ा सा टाइम में फटाफट खत्म करें। तो अब हम थोड़ी सी molecular modeling का बताएं। देखो ये पूरी प्रोटीन थी, जूम किया गया, ये हमारा स्मॉल मॉलिक्यूल है। ये जो आपको ब्लू कलर दिख रहा है दैट इज ऑलरेडी रिपोर्टेड इनहिबिटर, और जो आपको एक डांस करता हुआ दिख रहा है दैट इज अ न्यू कंपाउंड। तो वो वहीं जा रहा है, पॉकेट देख रहे हैं, पॉकेट बन जाती है छोटी सी, इसके अंदर ये कंपाउंड जाता है। कंपाउंड कहो या लीड मॉलिक्यूल के मॉलिक्यूल कहो, लीड तो बाद में बनेगा। स्मॉल मॉलिक्यूल एंड प्रोटीन का इंटरेक्शन एट एटॉमिक लेवल एंड बाइंडिंग साइट ऑफ द टारगेट प्रोटीन एज वेल एज विल शो द फंडामेंटल बायोकेमिकल प्रोसेस, ठीक है। तो ये पॉकेट जो है एंजाइम में भी होगी, रिसेप्टर में भी होगी। तो इस तरह से बिफोर यू स्टार्ट विद यू मस्ट नो द प्राइमरी स्ट्रक्चर ऑफ ए प्रोटीन, सेकेंडरी स्ट्रक्चर ऑफ ए प्रोटीन एंड देन टर्शियरी स्ट्रक्चर ऑफ ए प्रोटीन एंड द क्वार्टररी स्ट्रक्चर ऑफ ए प्रोटीन। अगर ये नहीं आता फिर आप मॉलिक्यूलर मॉडलिंग नहीं कर सकते, छोड़ दो, ठीक है। आपको पता होना चाहिए प्रोटीन स्ट्रक्चर। तो देयर आर अराउंड 20 नेचुरल अमीनो एसिड्स और अननेचुरल भी हैं, बहुत सारे हैं, चेंजेस भी होते हैं। तो ये अमीनो एसिड्स का पता होना चाहिए, बिकॉज़ इफ यू नो द अमीनो एसिड हाउ दे आर लिंक्ड, जब एक चेन लंबी हो जाती है इट स्टार्ट्स कॉइलिंग, तो क्वाइल होती है तो सेकेंडरी स्ट्रक्चर में कन्वर्ट होती है, जिसका अल्फा हेलिक्स और बीटा शीट्स, ठीक है। फिर और क्वाइल होती है टर्शियरी स्ट्रक्चर, फिर और क्वाइल होती है तो क्वार्टररी स्ट्रक्चर। तो जनरली टर्शियरी क्वार्टररी स्ट्रक्चर्स आप देखते हो पूरी फुल प्रोटीन का, और ये प्रोटीन भी अलग अलग तरीके से बिहेव करती है, ठीक है। तो अगर आपको ये पता है देन यू कैन गो फॉर फर्दर स्टडी। तो इस तरह से देखो ये अमीनो एसिड्स हैं, और इन अमीनो एसिड्स को डिवाइड किया गया है किसके बेसिस पे? स्मॉल, न्यूक्लियोफिलिक, हाइड्रोफोबिक, एरोमेटिक। जिसमें एरोमेटिक कौन से? जिनमें बेंजीन रिंग है या एरोमेटिक रिंग है। और फिर अमाइड वाले हो गए जैसे एस्पार्जिनिन, ग्लूटामिन, हिस्टिडीन बेसिक हो गए। इन्हीं अमीनो एसिड्स के बेसिस पे सारी मेडिसिन बनी, ओके। तो ये अमीनो एसिड हो गए। लाइसिन, आपको पता है ना हिस्टोन में लाइसिन अर्जेंट बहुत ज्यादा होता है, जिसकी वजह से बाइंडिंग और अनबाइंडिंग होती है डीएनए की। दे आर रिस्पॉन्सिबल एक्चुअली। एंड देन यू हैव ग्लूटामिन। तो एसिडिक अमीनो एसिड भी है, बेसिक अमीनो एसिड भी है, ये सारी चेन एक प्रोटीन में अगर बहुत सोचे जरा, तो एक प्रोटीन में ज्यादा भी हो सकते हैं, इक्वल प्रोपोर्शन तो नहीं होता, बट सम अमीनो एसिड्स आर मोर। ग्लाइसिन इज द सिंपलेस्ट अमीनो एसिड, बाकी सारे अमीनो एसिड्स कायरल हैं। कायरल समझते हो, एसिमेट्रिक सेंटर है। और जो हमारी बॉडी जो अमीनो एसिड खाती है वो कौन सी लेती है? आर या एस? एस। ओके, CIP रूल के अकॉर्डिंग। तो आप ये प्रोटीन, तो ये सारा भी प्रोटीन जो है अमीनो एसिड की बनी हुई है। अब अमीनो एसिड में भी क्या है? कार्बन, नाइट्रोजन, CO, ऑक्सीजन। तो ये ऑक्सीजन, ये जो ऑक्सीजन है ये हाइड्रोजन बॉन्ड बना सकता है, हाइड्रोजन बॉन्ड दे सकता है। जिसके पास हाइड्रोजन है वो दे सकता है, जिसके पास हाइड्रोजन नहीं है, इलेक्ट्रोनेगेटिव एलिमेंट है, वो ले सकता है। तो वो फोर्सेस क्या है? व्हाट आर दोस फोर्सेस दैट माय कंपाउंड, माय ड्रग विल गो एंड सिट इनटू द पॉकेट ऑफ द प्रोटीन टू एडिटिव? देयर मस्ट बी सम ड्राइविंग फोर्स। किसी को अच्छा लगता है तभी तो हम उससे बातें करते हैं। Why it will slip into the cavity? Because it will make some bond. अब आप दूसरा जो मर्जी बॉन्ड समझ लो आप, अच्छे वाला बॉन्ड, बुरे वाला बॉन्ड। सो एक केमिस्ट्री होगी इन दोनों के बीच, स्मॉल मॉलिक्यूल्स और मैक्रो मॉलिक्यूल। वो पॉकेट के अंदर एक बॉन्ड बनेगा। वो बॉन्ड टेम्परेरी ही होगा, इतना स्ट्रॉन्ग नहीं होगा, लेकिन कुछ देर का तो होगा, जिसकी वजह से थोड़ी देर तो जेनेथिन से यूरिक एसिड नहीं बनेगा, राइट? सो दैट बॉन्ड, so this bond is due to their this structure. आप देख रहे हो पॉजिटिव चार्ज, नेगेटिव चार्ज, COH वाले हैं कुछ। तो this is the main side chain is responsible for binding to our molecule. जो हम मॉलिक्यूल भेजेंगे वो मॉलिक्यूल इनसे प्यार करेगा और बैठ जाएगा इनके साथ गप्पे मारने। कैसे बैठेगा? थ्रू हाइड्रोजन बॉन्डिंग, कोवलेंट बॉन्डिंग भी हो सकती है। ये एरोमेटिक रिंग है, इसके साथ भी पाई कटायन हो सकता है क्योंकि इलेक्ट्रॉन दे सकता है। ये कई तरह की बॉन्डिंग हो सकती है, राइट? So there are many forces, इनको हम forces भी बोल सकते हैं and इनको binding भी बोल सकते हैं, bonding भी binding भी। So और ये जनरली जो फिजिसिस्ट जानते हैं, बायोफिजिसिस्ट, कि वो कैसे एक्सरे स्ट्रक्चर्स को, एक्सरे स्ट्रक्चर लेके आते हैं। हमारे यहाँ पे दो साइंटिस्ट थे मैडम, जो आई थिंक he was Rajan, Dr. Rajan, he was biophysicist, so he used to crystallize the structure. So we are still working with him and he is crystallizing my compound with the xanthine oxidase protein. So if my compound is, I would like to see how my compound is sitting into the protein cavity. Okay, because I have doubt that it might have a different binding force, which is earlier reported by. So binding force may vary. Okay, so these are the techniques where you can use, for screening of compounds. NMR wala bhi, this is NMR based. We also have NMR here, and through crystallization rules. Okay. So this is one example that it is an example of PKM2 protein which is dimeric, equal portion है, देखो half, है ना? Dimeric, और इसमें इस तरह से binding forces हो सकते हैं। So one is fructose binding site where fructose can bind, other is active site जहाँ पे आपका compound या कोई natural ligand bind कर सकता है, other is activated binding site, कुछ और inhibitor भी bind कर सकते हैं जो activate कर दें इनको, ताकि एक और quaternary structure बन जाए और tetrameric form बन जाए। So it is a metabolic enzyme actually. It is not a simple दूसरा enzyme, it is a metabolic enzyme. So I'm just giving you the glimpse that if you know the structure of a protein, you can think many things and you can design a better compound. Little bit chemistry background is also required. Not little bit, very good. That's what I called very good, madam. Okay, so this is how the 3D QSAR looks like. You will see some contours and some maps that where electron donating power is more required or electron withdrawing power is more required. Okay, so here you can see, just see this figure. This is very simple. This is a protein and this is just a cartoon type. This is a protein and this is my drug. It is perfectly binding. The score is -9.1. And here the same drug is not binding perfectly. Can you see this? It is not binding perfectly. So the score is -1. I told you in some softwares, higher the minus value, better is the binding. So this one is better binding than this. So you can predict delta G, delta H means how the free energy is released, means how much binding is there. Okay, so that will give you that scoring function. See, guys, if you work on computer or molecular modeling techniques, even I do not know, there are many algorithms going on behind the screen. Okay, when a software company sells it, so you have to just follow this thing, but you have to be smart how to use it, because the rule is garbage in, garbage out. If your data is wrong by the first stage, you will have a bad output. Okay, So these are the approaches. So this is the, this is the kind of like this is my compound sitting in the cavity. And I remember I told you these are the neighboring amino acids. How they are shaking hands with my compound. See, this is hydrogen bonding here. The dotted line, can you see this is hydrogen bonding here? And some other bondings also. This is the bonding here. So, and they are allowing, like methionine is having interaction with this sulfur is having interaction with this distance. This is a distance actually, not the interaction. So here is the interaction, some weak, some strong. So hydrogen bonding, it is less than, it is between 1 to 2 angstrom, the interaction is strong. Okay. The best example of hydrogen bonding is anyone? Anyone? Best example. Protein structure is there. The stability, it gives stability. DNA. Adenine. Thymine. G, C. So though it is a weak bond, but when it becomes 2, 3, 4 by 1, it's near that. So so same way. So more hydrogen bonds. And this is, I think, it's the second last slide somewhere. So this is the one of the tyrosine kinase enzyme for protein, which is having, so this, madam, what is this color? I'm colorblind. What's the color of this? Purple. Yeah, purple, and this is a blue color. So this purple is sitting in this cavity. Can you see the cavity space? This is the whole protein, and this is sitting in the cavity. This is type 1 inhibition. You can predict the inhibition type also. Type 1, when it is binding to the main cavity active site. Then you have a type 2, because there is a one chain of amino acid, side chain of amino acid. If this is also interacting, it is called type 1. When this is called DFG motif. DFG means asparagine, phenylalanine, glycine. These are 3 amino acids hinge reason. So if it is away, it is called type 2. And if my compound is binding some other pocket, type 3, and type 4, this is another. This is near to the. This tunnel is between the active site and this. When it is other than the active site, is called type 4, which is nothing but allosteric. Okay, so these are the different binding modes can be there, and my compound can shake hand with the protein active site reversibly or irreversibly. Reversibly means very for one moment, and irreversibly permanent shaking. Like if my compound has some double bond, some triple bond, biplexy property. So proteins, remember amino acids, amino acid structure, amino structures have IO2, cysteine. Insulin also cysteine is there. This is the diamine. So that sulfur can attack on my compound and get permanent covalent. Okay, so my compound can sit it and it will sit till the protein dies. Okay, so it will sit for the longer. So this is just a glimpse, how your molecular modeling can be useful. So these are some softwares available. You can go Google and whatever. Like these are some openwares, freewares for academic use. Okay, these are paid softwares. Like we have Schrodinger with us. Like which has so many things like USAR or molecular docking and other things. So these are freewares available. Autodrom, people generally use Autodrom, Bina. Some other versions are also there. Okay. Yeah. Thank you very much. I'm sorry. Some of the students were sleeping. I know.
In post lunch effect there are because they had lunch and this.
Any question?
Any
question?
इधर भी पूछेंगे क्वेश्चन लंच के बाद बहुत कम हो गया लंच पहले तो ज्यादा था any question? No.
Still waiting. Yeah.
That will come. Somebody is typing, I think.
Yeah. We'll wait for 1 or 2 minutes. Sir, great talk. Love it. Online.
Thank you, Professor Rajkumar.
Yes.
Sir,
Your words of wisdom.
Thank you.
It is my great honor it is my great honor to request the dignitary to facilitate Professor Rajkumar as an expression of gratitude.
ये मेरा प्यार है कुछ लाया
हमने लाइट एंड उसका बॉन्डिंग करवा दी
Thank you. Because this was the last talk for the event. I thank all the speakers for the inspiring words and the participants for their rapt attention. Before heading to the valedictory session, I request all of you to partake tea and snacks. One person valedictory program.
Very question I have. Question I have.
Okay, okay. It's another sir. No, no, no. कोई बात नहीं. होगा. Just ignore. Ignore it.
Reply, we will reply through mail.
अरे कोई बात नहीं. ये हमेशा ये आता है.
एक बार
just one or two volunteers can come. If you are interested.
ये वाला?
Volunteers may
This one?
please come forward.
ये कैमरा चालू है।
Sir, आपको नहीं दीजिए?
Thank you very much for coordinating this program. For me, I think I'm from Adesh University. First of all, I came to know the faculty of Central University because it was my desire that we have two universities and aim that we should know each other. And thus, there are a lot of things that I have learned. Although my department is forensic medicine, but still, I remain research committee for PG students. So a lot of things have been clarified. Although right now, I lot of bit bent out of my head, but still, I understand many things. But,
The purpose is, you see,
Yes.
the purpose is to make students aware
Yes.
of
Yes.
what all new is going on
Yes.
in the field of research. So this is also one area which is coming up, like.
but we are aware that how the structure is designed, how the steps, like where you work, to tell that to the table that where you work and then where the industries work and then everything that starts of the thing that you understand. And then before that, statistical was also very big. Plus the example he has given up, that was very interesting. That's all in the morning also we were second first session, we have explained everything, the procedure of we present the papers and how we do the, so first everything was good. Thank you.
Anyone else from the students?
आप बोल के आइए.
On the occasion of National Conference arranged by King's and Central University, Punjab. And I would like to firstly thank to Professor Dinesh Kumar Singh, Executive Director AIMS, and Professor R.P. Tiwari, Vice Chancellor of CUT, Fatinda. I am currently doing my master's in food science and technology, and we are right now going to do research, and it is very important to know how we are going to perform our research activities and all, and the methodology is very important topic for us. That's why I came here, and I think I got a brief idea about what I need to do in my next semester. So I would like to thank all the teachers and the university, and also our teacher who brought us here. Thank you, ma'am, and thank you, sir.
वो तो फिर ट्रीट करना
Let's move to the certificate distribution session now. I request the dignitary to come on the stage. Participants will be called one by one.
Now, please.
Starting with MRS speaking, Dr. Pramod Kumar Goel. Mr. Manav Jindal.
Manav is plus C
Mr. Sandeep Singh.
थोड़ा इधर आते हैं.
Mr. More Uday Kumar.
आपको नहीं चाहिए सर्टिफिकेट? या आप भूल गए सर्टिफिकेट?
Mr. Harshit Kumar Tripathi. Mr. Koluri Sujon. I'm sorry if I'm not.
Yeah, let's go in.
Miss Simran Sidhu.
Yeah, next.
Miss Advaita S. Miss Shrishti Thakur. Miss Archana Miss Ria, Miss Shweta Chaturvedi, Miss Aditi Sharma, Miss Tasaduk Musul, Mr. Harjeet Singh, Miss Neetu Rani, Sukhjot Kaur, Miss Manmeet Kaur, Miss Jashanpreet Kaur, Miss Sonia Randhawa, Mr. Aman Maan, Miss Jashima, oh, sorry, Miss Bhumika Arora, Miss Karampreet Kaur, Bhumika Arora, Miss Ramandeep Kaur, Miss Randeep Kaur, Mr. Anmol, Miss Bhavna, and Mr. Vikas.
Mr. Vikas, ये अपने volunteers की बनाए हैं कि नहीं?
If anyone is remaining, they can collect afterward. There might be glitching, making. And the participants from the Central University of Punjab, they can collect it afterwards from the reception. Today's event was full of good learning experiences and developing basic research skills. Implementation of this knowledge will surely help us overcome any hurdles in our research. With this, I extend my invitation to Dr. Jitendra Kumar Patnaik, Head Department of Geology, to conclude the event and deliver the vote of thanks.
ठीक है, आप मुझे फोन कर कोई बात नहीं, आप 6-7 बजे नहीं वो भी नहीं, अगर आज नहीं हो पाएगा कल मुझे
Good afternoon, everyone. So before delivering the vote of thanks, I would like to summarize today's event. And before starting that, I would like to inform you that, like morning also you heard that this program is supported by INEAS. When you look at this INEAS is the Indian National Young Academic Science. There, if you see the INEAS activity, there you will find that lot of outreach activity we are actually conducting. As a INEAS member, we are conducting lot of activity, where one important aspect is like we go for the rural area for the lecture. We organize different kind of science camp. We also nowadays are encouraging to conduct this conference where we are inviting the best research scholar, even postdoc student, to tell them, to encourage them how to conduct a good research. So this is the part of that outreach activity where we have organized this conference. And if you see the title of this particular event, it is Basics of Research Methodology. You know, nowadays in PhD, in the course also UGC also written that you have to complete this research methodology course. This is mandatory. Even research ethics now it is mandatory. So keeping all this in mind, we invited this research scholar and the MSc secondary students, those are going to start their research career, to attend this particular conference. And when we initially planned this particular event, we thought that we should restrict to the physical mode, but later we thought in the physical mode we cannot accommodate more students, more participants rather. So we kept it as a hybrid mode, so that some participants from the nearby institute, they will attend physically, and others they can join online. And when we open the registration, like more than 335 registration actually we got. And our seat was limited, like for physical mode it was 60, and for online it was 150, but at the last moment we increased to 200 to accommodate, because we have some technical restriction also, how many we can accommodate in the either Google Meet or in the Zoom or whatever account, the virtual mode. So we restricted to 200, and you know, from the morning onwards we are listening all the lecture. And this particular event, as you know, from the flyer also and from morning also, you know, which is organized by CUPB in collaboration with AIIMS Bathinda, and in the morning also many lecture also you heard. And so what I will do, I'll briefly just summarize the lecture. The morning session, we started with the art of scientific writing and project designing. Professor Anjana Munshi, she very nicely explained about the how to write a scientific paper from each stage, starting from the inception of the research idea to the final, like Galileo proof, all this, like each component of the paper, she very nicely explained in the first talk. And in the second talk, it was by Dr. Sachdeva Pani, about the good research designer. He explained in a different perspective, because when we are looking at the research, the domains are like we are actually enriching the particular discipline knowledge. Okay, so we cannot restrict only to the science or particular stream. So to give an overview and from the different perspective, we heard about like how to design a good research. And the third talk was the role of search engine in the present day research. As it's very important, and morning Madam also explained that when you are writing the research problem, first we have to look for the research gap. How to find the research gap? So the literature review is a very important key component of the research. So there, Dr. Sudhir explained about the role of search engine in the present day research. What are the different type of search engine and how we can make use of those things that we heard before lunch. And after lunch, we had three talks. The first one is was ethics in medical research. Yes, in the research ethics, we follow that. In the medical research also, there are some other additional ethical things that we learned. We learned from Dr. Abhinav Kanwal. And then the next talk was data analysis, interpretation, and presentation. As we know, that statistics is a very key component of the research when we are talking about the quantitative and other aspects. When we are presenting the statistical analysis is very important. So that we heard from Dr. Madhur Verma. And the last talk was
by Professor Rajkumar. It was about the fundamentals of drug design. That talk was recently concluded before tea. So this was the overall technical, overall talk of the technical sessions, and it was very enriching, and it was like covering most of the domain of this research methodology or basics of research when we are going to start. So that was covered in this. Before that, I would like to show the graph. If you see this, around in this particular conference, 62% of participants were online, and offline was 21%, and 70% of participants, those registered actually through online mode, they are attending through YouTube link. And if you look at offline participants, you can see here like different institutes, Central University of Punjab, our own student, Akal University, Balafari College, then AIMS, MRSPTU, then so this is Central University. We have one student here, so he was participating in the offline mode, and from the others university, people are attending offline mode. If you look at the online mode, you can see it is completely it is covering whole India, all type of institute, not only university, institute, IIT, CSR lab, all participate from different organization and from different state also. They joined today, and they attended all the and this is the if you look at the position, like faculty members are there, PhD student, MSc student, technical staff, MTech student, BSc student online they joined, and the UG student, BS student, they online joined and they're attending to YouTube. So this is like overall the distribution of the participants from the different institute and different organizations. Okay, coming to the vote of thanks. To make an event successful, contribution from many or the support from many person, many sections is required. So to have this event successful, first is the guidance. Guidance is coming from the head of the institute. So first I would express my sincere gratitude and thanks to our Honorable Vice Chancellor, Professor R.P. Tiwari ji, who always support us to organize such kind of event conference. And I also express my sincere thanks to Director AIMS Bathinda, Dr. Professor Dinesh Kumar Singh. He also supported us to start this particular conference. And I also thank our Dean Academic, Dean in charge academics, Professor Usrika, Ramakrishna Usrika, in the morning session he was with us. And I thank Director Research and Development, Professor Anjana Munshi. I thank all the participants who joined online as well as offline. I thank all the speakers from the morning session and the afternoon session who enlightened us through their research, their knowledge of wisdom, where we all got benefited from this particular conference. I also thank the computer section, because without technical help, Mr. Davinder, he is there from yesterday onwards. We tested this, but unfortunately in the morning we had a technical glitch, but somehow he managed by bringing all the link and other things. And I also thank engineering section, security, state office to support us to organize this particular event. I thank all the volunteers who work, lot of work they actually they have done to organize this, to moderate the session, to arrange the certificate. Small things are there, lot of things are there for the conference that they have contributed immensely. I also thank all the organizing committee members. They continuously they supported this particular event to become successful. I also thank all the faculty members, staff from the university as well as from the department who are directly or indirectly involved to make this conference successful. I also thank AIMS Bathinda faculty member Dr. Paramdeep, who was my co-INEAS member, as well as his staff member and students to support this particular conference to make it successful. With this, I conclude my vote of thanks. If I miss anyone, any name or any person, I'm sorry, but yeah, I tried to put all the names. Okay, thank you. Thank you. So, I request all the participants to rise from their seat for the national anthem. Online participants, if they can switch on their video, we can take a snapshot.
ये तो देखते हैं time switch on the camera so that we can take a snapshot.
अब नहीं करेंगे सर।
हाँ
अब नहीं करेंगे।
कर एक तो कर लिया तो हो गया
वो अगर बोल के मैसेज
हो रहा है गुड हो रहा है हाँ? क्या थोड़ा वेट करते हैं ना इसके बाद स्नैपशॉट यस हो रहा है धीरे धीरे बस 4-5 सी है
वो ले ले हाँ जो भी है ये कर दो
स्क्रीनशॉट कहाँ इसको कहाँ है स्क्रीनशॉट ले लें स्क्रीनशॉट
वो स्क्रीन हाँ एक स्क्रीनशॉट ले लो दो एक लेना पड़ेगा अलग अलग ये वो एक स्क्रीन में सारा नहीं आएगा तो ये में आ जाएगा अलग अलग दूसरा स्क्रीन पे ले
ले लिया सर
और कितने पार्टिसिपेंट है और
मैक्सिमम ले लिया सर जितने भी आए हैं
और एक स्क्रीन को आप जाओगे ना दूसरा स्क्रीन को दूसरा स्क्रीन में आ जाएंगे
नहीं सर सारे आ गए हैं इसमें सारे आ गए हैं सर यहाँ पे सेम ऐसा डिजाइन कर लीजिए
ओके ओके तो थैंक यू बोल दीजिए थैंक यू एवरीवन
सर एंड
थैंक यू एंड थैंक यू मान के आप
ये आप लोगों को भी दिखेगा इनके पास ये आप रखिए ये आपका है सर
ठीक है, हम इसको बंद कर लेते हैं, क्लोज कर लेते हैं इसको।
ये कैमरा उठा लेना सर, एंड कर दो इसको।
हाँ, कर दिया।